Hello everyone and welcome to the PSP Homebrew Developer Conference of 2025. I hope everyone can hear me. Would be nice if some people could confirm. Then I'll continue. Great. Okay, then today we have 11 presentations on basically on what people are working on in the community. We have all kinds of new things for the PlayStation Portable, and I hope you're all excited. So this event is hosted by the PSPDEV community on Discord, and we are also the people who maintain the tools for making homebrew. And if during any of the presentations today or after you have any questions, feel free to ask in the chats. Either on Discord is fine or on the YouTube comments. People will be taking a look at those. And to get things started, I will first give a presentation on specifically on what has actually happened in the last year. So let me activate screen sharing. I will just quickly make sure that it's actually going. There we go. Oh, that was one too far. So my name is Wouter. You might know me as Shark Wouter on GitHub, and I will be talking about what has changed in PSPDEV since the last PSP Homebrew Developer Conference. And honestly, we changed a lot. Like, a lot of work has been put in. We had over 300 pull requests. We closed quite a few issues. We have some new libraries, lots of libraries updates. And we even created 2 new websites, which I will talk about later. And we did 20 releases, which before, I think we did like 1 maybe. But I'll talk about all of that later. So what did all this work get us? So first things first, we have our website, and it's pretty great now. pspdev.github.io. Whenever you ask a question, how do I do this basic thing, you might get this linked because it has so much info. Let me show you. So this is what it looks like now. And we have a lot of different stuff on it, like how to install for each operating system we support. Like if you have another platform you would like to add, contributions are welcome. Then we have a basic guide on how to use the toolchain. This is mainly focused on Windows, but it will work on any system. And it also shows you like install this editor, and this is how you create a file in it, and this is how you build it. And then we have some basic programs like how do I draw something, how do I react to controls, how do I play a sound, things like that. And very important, if you are developing for the PSP and you have a PSP, you should read this once, because this will make your development way faster. You will be able to compile and directly start the program on your PSP over USB. And it's amazing. It also has a lot of info on how to debug, okay, my game crashed, what is happening? Yeah, and I would like to thank Diamond 3 for his help with the theming is all his. And then we have even more. We have another website, namely we have the package index now. So right now we use Pacman to package our libraries, and there wasn't really good overview of what libraries we had available. You could run a command for it, but now you can also check on the website. And for each library you can see like an overview, and we have some short instructions on how to install specific library, but most of them should already be installed. Like if it says here in groups PSPDEV default, then you should already have it if you downloaded the latest version of the toolchain. Yeah, and I would like to thank TPIMH for his help on that one. And something exciting, we have bin utils 2.44 now, which is the latest one. I think it came out in March or February. And I would like to thank David for that one. And we even have the very, very latest GCC. Like this came out like 1 month ago, I think. And that's thanks to Francisco. And now we have automated releases, which we didn't have before. Like we have each month on the first day, we have an automated release. And it looks like this. It will automatically generate a list of all the pull requests that went into it. And it will attribute the people that created those. And if you look at our history each time, you can see that every release so far has had quite some changes. And we sometimes also manually do releases. Like this one is not on the first. And we do that when either we fix something that was really broken, or what's a good example? Like we released a new version of GCC and we didn't want to let people wait on that. And this, we have a little tool now for managing libraries, which we didn't have before, and I think many people don't know this yet. It's called PSP Create License Directory. And what it does, it creates a directory called third-party licenses, in which it copies the licenses for the toolchain and for all the libraries that you use. You can just tell it PSP Create License Directory and then SDL2 library, for example, JSON CPP, or whatever other library you like. And it will even add the licenses for dependencies of those packages. So you know what you have to comply with, and for users it's also nice to have this information. And then SDL3 came out. SDL is a library to do platform specific things without platform specific code. I will talk about this later again, but they released version 3 and on release it worked. We have it packaged, you can use it, and the SDL community did a great job on that one. And then some of the new libraries we have, like there's a lot more, but these are some of the ones where I was like, maybe some people recognize this and be happy about it, but there is a lot more. You can go look on our new package index. And if you want more, then you can either wait for us to do more, or you can come help us out. On our website we even have a page on how to contribute, and it shows like the different projects we have. So if you'd like to do that, then please come and help us out. Right. That was the button. Okay, so now for something different, we have a presentation on translation of Puyo Puyo 20th Anniversary Edition, which is given by what was that again? You will see it in the video. I will play.
Hello everyone, my name is Yude, and I'm excited to talk about Precise Museum's English patch for Puyo Puyo 20th Anniversary on the PSP. I'll be talking about the translation side of things, and then I'll pass it over to Armando for the technical portion. So without any further ado, let's dive into it. Here's our little logo. As a quick aside, I'm an apprentice translator and a proofreader with Precise Museum. I also handle a few PR things, like posting on the social media and updating the website. Now, what is Precise Museum? We're a team consisting of 25 members of a variety of roles, like translators, proofreaders, programmers, video editors, and image editors. You can see the breakdown of our roles here on the slide. We have a lot of very talented people on our team who contribute to making our projects reality. So what do we do specifically? All of our projects are related to Puyo Puyo, which is a Japanese action puzzle game series published by Sega. So we translate things like comics, interviews, manuals, audio dramas, mobile game exclusive content, and novels. Our first projects when we started out mostly consisted of these things before we eventually pivoted to patching games as our team grew. So far, we've released 3 English patches: Puyo Puyo 20th Anniversary for the Nintendo DS, Puyo Puyo Chronicle for the 3DS, and our most recent release, Puyo Puyon or Puyo Puyo 4 for the Dreamcast. Currently, we're wrapping up our revamped translation for Puyo Puyo 20th Anniversary, which will be released for the Nintendo DS, the 3DS, and the PSP. Incidentally, this is the patch that we're discussing today. Now, what is this game? So many versions on so many consoles. Well, it might be better to just show you what it is. So what you just saw in the video was the core gameplay of Puyo Puyo. It's a competitive puzzle game where you have to arrange the pieces, or the Puyo, on the board to create chains. Not only is the gameplay addicting and really satisfying, it boasts a cast of more than 24 characters, all fully voice acted and drawn in a really adorable art style. Now, what makes this game so special? As you might have guessed from the title, which I've repeated multiple times, this game was released to celebrate the series' 20th anniversary. It's also a hallmark in the franchise for bringing back characters from the franchise's parent series, the dungeon crawler RPG Mado Monogatari developed by Decompile. This game was not originally owned by Sega, and so there were a lot of characters in the older games that were brought back in 20th anniversary. Additionally, it has 20 playable game modes for both single player and multiplayer. This amount of modes was only recently beaten last year with the release of the Apple Arcade exclusive game, Puyo Puyo Puzzle Pop. Now you might be thinking to yourself, why would you make 3 translation patches for the same game? And the answer is that we've always wanted this game to be accessible on multiple platforms. But when we started out, we lacked the programming savvy necessary to patch anything other than Nintendo DS, but we've since leveled up. With all that experience under our belt, we can offer a revamped translation for both the 3DS and the PSP versions of Puyo Puyo 20th Anniversary, which, unlike the Nintendo DS version, offer full voice acting for the story mode. I've broken down our translation process into 3 phases: the translation phase, the proofreading phase, and the playtesting phase. In the translation phase, we start by organizing the extracted text into files, which are then assigned to translators. Usually we just keep track of this process with spreadsheets, and we have a lot of spreadsheets, but this helps us to keep track of both the game's internal file structure and if there are any repeated files or files with similar dialogue. A translator then does their first translation, and one of our head translators, Ingu or Neni, revise it for any mistakes once it's complete. They also double-check each other's work. In the proofreading phase, we pass the revised scripts to proofreaders who read through it for a few weeks. We usually implement fixes that everyone is in agreement on here, like obvious errors or typos. Then we poll. This is where we take disputed suggestions or lines with multiple possible revisions and put them into Discord polls for our proofreaders to vote on. Finally, we move on to the playtesting phase. Basically, we just inject the text into the game to see how it works. Some lines might need to be changed to fit into text boxes, or the way dialogue is split up might just need to be altered to flow better as it shows up in a cutscene. While technically the playtesting process happens at or near a game's completion, it's an important part of translating to me, since seeing dialogue in action can give us a new perspective for the flow in a scene. I've only briefly covered this phase here since Armando knows more about the technicalities of this than I do. As for revamping the translation of Puyo Puyo 20th Anniversary, it generally followed this same workflow. The entire script of our first release was translated by Ingu, who then took another pass at it to update the translation since we wanted to release a new version. Then, Neni revised it by comparing it against the original Japanese with audio to measure accuracy of the intent, the affect, the comedic timing, and so on. Discussion between them happened in Google Docs, and after resolving any differences in interpretations of the Japanese, the documents were passed to proofreaders for input on wording changes and to make the dialogue flow more naturally. The rest followed the process as described before. So the advantage of this process is being able to maximize consistency in character voice and style while minimizing errors. Additionally, there are always puns, jokes, and other weird character quirks to tackle in Puyo Puyo. We want to be able to balance that unique flavor with crafting an enjoyable experience for English players that parallels the Japanese one. And this ranges from putting ghost puns into the script to making a character who speaks entirely in katakana equally unreadable in English. And we also put in a lot of effort to ensure the quality of our translations, and this helps us to avoid something called the fan sub problem, aka releasing text that translators think sounds good in English versus what non-Japanese English speakers think sounds good in English. A good example is when two characters are having a conversation and one says the other's name. A novice translator or someone who's stuck in the Japanese grammar mindset might just translate this as their name, when in context it's being used similarly to you in English. For example, in this scene, Amity is talking to her friend Liddell, and we've translated it as, "You'll always be with me too. I mean, we're friends after all." But a novice translator might translate it as, "Liddell too. We'll always be friends." So, as you can see, a lot of effort went into revamping our translation, but now we get to talk about how all of this and the images were put into the game. And that's a wrap from me. I'll be passing the baton over to Armando now.
Thank you very much, Yude. Hello everyone, my name is Armando, and I was the one in charge of applying the translation to the PSP version of the game. So let's talk about what it took to get that done. But before that, I would like to thank Nick for his amazing contributions to the Puyo Puyo community. He made the majority of the tools that we used to make this patch possible. To simplify, this is the process to successfully patch a game. We need to access the game files such as graphics and text, we need to modify said files, and then we need to inject them back into the game. And finally, we need to test for any issues or mistakes that may have arisen. That is essentially the workflow. So let's start by dissecting the PSP version of the game. If we extract the ISO, we'll find a big file called game.dat. This file contains every asset used in the game, including images, text, sound, animations, and pretty much everything. Thankfully, Nick has made a tool that can extract and repack this file for us. Because of the way they're stored in this file, they'll lack any metadata such as name or file extension, so it was necessary that I checked what each individual file was and what it contained so I could label them for easy editing. Graphics were easy to find, as they were stored inside regular zip files in the GIMP format, a standard for the PSP, and the files inside the zip archives did retain their names, which definitely helped. Text files were a little trickier to find as they lacked any extension. However, they were usually paired with an FNT file and two header files that contained some information about the contents of the text. Let's update some text. Once again, we will be using one of Nick's tools, Puyo Text Editor, to convert these files into readable JSON files that we can edit. However, before we can start editing the text, we need to set up a font with all of the characters that we need. If we open the font in a text editor, we will find the following. Two values that define the height and the width respectively of a grid, the amount of characters in the font, and then we have the character data. For each character we will have its white character representation, in this case it's this Japanese character right here, and here we have its width in pixels. After all of the character data, we find data for a GIMP file. This is a texture that contains the glyphs for each character, aligned with the grid defined at the beginning of the file. So now we need a font that contains all of the characters that we're going to be using, plus some punctuation characters. Let's try this in-game with some text. You'll notice that some of the characters in the text appear completely wrong. Turns out that for whatever reason, the game's math for variable width characters breaks after the first row of characters in the texture. If a character is not on the first row, it must have a width equal to the horizontal grid size. Otherwise, the logic for the font crops a completely different cell on the texture. Unfortunately, I lack the technical know-how to identify and modify this piece of code, so I had to work around it. This took a lot of iteration, but eventually I landed on a font that looks like this. I had to be very selective about which characters were allowed to be on the top row, to minimize the amount of characters with unnecessary spacing. Okay, let's try it in game, and seemingly at random, the text is sometimes very blurry. This only happens in spots where the text is automatically centered based on the longest line, such as during the game's cutscenes. Let's zoom in to better see what's happening. The game tries to center the entire block of text based around the longest line, but when the total width of the longest line is an odd number, the center line lands in the middle of a pixel, so the text gets misaligned with the pixel grid of the screen. To fix this, before converting the text, a Python script checks if the width of the longest line is odd and then adds an extra invisible character that adds +1 to the total width, and now the text is no longer blurry. Now that we have a way to edit text and graphics, a way to automate the process was necessary. A Python script was built that scans a patch folder for any image and text files, and if it finds it on a JSON named last modified, it will compare its modification date. If it does not match, the file is marked as modified, and then it is converted, and if applicable, it is packed into its respective archive. Then we rebuild game.dat. We update the ISO, and we do a first pass of testing to see if there's any mistakes or crashes that we can catch. And with that, we have everything we need to apply the translation to the game. However, while waiting for the translators and proofreaders to finalize the text, I started experimenting with the animation files of the game, which are used extensively in the game not only for character animation, but also to define menu layouts. They are the SNC files you'll find inside most zip files in the PSP version of the game. They're similar to Flash in a way, where you have sprite objects, layers, and animations. It's a somewhat simplified version of the layout format used in Sonic games during the early 2000s, such as Shadow the Hedgehog on the PS2 and GameCube. Combined with the graphics inside the SNT archives, we get this result in game. Opening one of these files in a hex editor, we'll find a bunch of patterns. Without going into too much detail, this is essentially how I reverse engineered the format. I essentially just poked at the numbers and saw what happened. By modifying these files, loading up the modified file in-game and observing its effects, we can get a good idea of how the file is set up, what it stores, and how we can manipulate it. As you can see, it stores a list of textures and their sizes, though it is not used in the game, so I usually ignore it. Then a list of cropping points indicating the texture indices and their coordinates. Then we have banks that contain elements that can hold a sprite and various transformation values such as position, scale, rotation, etc. And finally, we have animations, where each animation defines different motion tracks and keyframes for each element in the file. Knowing this, I created a Python script to convert these SNC files into JSON files that I could edit somewhat easily. Then, using the Godot engine, I built an animation editor that allowed me to intuitively edit these files. This essentially gave me almost full control over all of the UI and menu layouts, as well as character animations in the game. I say almost because some of the files were hard-coded to contain some specific data in a specific way, such as, for example, element names being in a specific order different from their indices. I use this to modify the layouts, such as, for example, here in the school menu, where I moved the icons that were covering some of the text to the side. And that would have been it, but the ability to edit these files also sparked an interesting idea. You see, the 3DS version of this game did something very interesting. Since it came out later than the other versions, they had improved most of the character animations, adding extra moving parts or adjusting timings, and in general they looked a lot nicer. Since all of the versions of the game use the same format with super minor differences that can be adjusted for, such as for example, fixed points being used on the 3DS version rather than floating points, I decided to port these animations to the PSP version of the game as an optional separate patch from the translation itself. To convert these files, I wrote a simple Python script that adjusted every element size and their positions to better match the PSP resolution, and then I created new sprite sheets for each animation file to account for the extra moving parts. And this is the result in game. As you can see, the differences can be pretty striking, such as with Feli's animation here.
Now, when will the English patches be available to download? Well, you will be able to download them right now on our website at precisemuseum.com. And with that, we have reached the end of our presentation. I hope it helped shed some light about what really goes into making a translation patch and the amount of attention and care that was put into this project, especially the translation and proofreading parts. Thank you for watching, and I hope you'll check out Puyo Puyo 20th Anniversary on the PSP. And also, thank you very much to the PSP Homebrew Discord for allowing the opportunity to showcase our work.
Wow, I can't wait to play Puyo Puyo in English. That was a good presentation, guys. Good job, Precise Museum. So for the next presentation, this one will be a bit more technical. It will be talking about the media engine. It's by MCID. I think some of you will look forward to this presentation a lot, and I'll just play it. Have fun.
Hello, I'm MCID, one of the developers from the PSP Homebrew community. I'm going to talk about the media engine and more precisely about the samples I've made recently. They are based on older discoveries and on more recent findings made by the currently active community. All the samples are compilable and have been tested on real hardware. They cannot be executed on emulators. The first one shows how to use a shared hardware spin lock to manage access between the two CPUs using a simple mutex mechanism. The second one shows how the CPUs can talk to each other using software interrupts, which is a powerful way to sync, send events, or manage shared resources. These possibilities were known, and the old PS2 Dev forum contains a lot of useful information which I relied on to create those two samples. Now about drawing samples. One shows how to draw directly from the media engine to the screen using a shared buffer connected to the DMAC Plus LCDC. Another one demonstrates how it's possible to write command list for the graphic engine from the media engine. So far, these things haven't been explored, and they really open up new possibilities. Next, we have the samples that use DMAC Plus, which is about a very interesting piece of hardware. It allows the transfer of data blocks, including chained ones, between the main CPU and the media engine in both directions. However, these transfers must be configured and triggered from the main CPU. We have 3 samples available on that subject. Then we can find demonstrations of some of the VME's capabilities, like the one using hardware registers for color space conversions. Basically, these registers allow you to convert YCBCR data located in the media engine's EDRAM into RGB in the main memory or the VRAM itself by requesting the VME. I was able to complete some missing information about them, such as how certain bits work, for example, how to separate the rendering between the two destination buffers, how to disable the second one, or how to manage line replication control. Thanks to Xerpi, if I'm not mistaken, and to everyone else who helped with these registers. Worth noting that the media engine's EDRAM is locally accessible at address 0. Accessing or manipulating it may require the correct virtual memory segment to be applied. I started early work related to the VME DMA, which has led to some practical results, especially around the primary DMAC. So you'll find the first sample on my GitHub using this primary DMAC, which is directly wired to specific buffers that appear to be involved in VME data transformations. These buffers can be activated on the media engine by enabling the bus, which corresponds to the DMA2 bus on the main system. They are 24 bits wide buffers, meaning that during transfers, only the first 24 bits of each word appear to be affected. They can be used cyclically and have a typical size of 0x 2000 bytes for the first 4 buffers. The primary DMAC is available at 0x0, 0x04000, and the internal buffers start at 0x04000000, not to be confused with the main VRAM address. This primary DMAC allows transferring data between internal buffers or between them and the main memory, and this time with control from the media engine, which can be an advantage over DMAC Plus in certain scenarios. Then we have a sort of DMAC multiplexer, which is a more complex case. I've managed to dig up a few things about it, but without documentation or clear understanding of what we are dealing with, it's still hard to move forward. So what I'm about to share is kind of speculative and disputable. Still, some parts have been verified in practice. This piece of hardware is located at 0x040F8000, and it actually works alongside the primary DMAC, meaning that some registers like the main control and the status registers are shared between them. The big difference is that it appears to accept multiple sources as input and can send data to multiple destinations. Sources and destinations can include the internal buffers, which I've confirmed, but it also seems like it can use hardware sources. Actually, I relied on empirical testing I've done, where I changed the main config registers and the source registers, then watch the output by displaying the result, drawing or writing their values. In some cases, I saw dynamic data coming through, data that changes in consistent patterns, like digital signals that could actually match FIFO outputs. These variations could indicate some kind of signal transmission. They may come from background processes, control signals, or maybe from other internal SoC operations. More analysis would be needed to clearly identify their nature. So far, I've identified 4 configuration registers, multiple source registers, multiple destination registers. The tricky part is that every config change seems to affect how sources and destinations are wired and behave. There is no working sample for this yet, because I haven't found a clear way to demonstrate it properly, given how little control we currently have over this hardware. I still don't know exactly how the VME really applies its process over the buffers. Other hardware registers could be involved. I haven't had any good results yet trying to use move to VME and move from VME instructions, which I think would be related to the VME DSP capability. In any case, we've made significant progress in understanding the media engine, and I invite you to explore all the available samples on my GitHub, MCIDCLAN, and more precisely, the repository named PSP-media-engine-examples, as it is at the time of this presentation. These examples will provide you more technical information. They demonstrate what we've learned so far and could serve as a foundation for further explorations. Thanks to Crazy C, H-Light, Celeste Blue, Art78, The Coxo, Davey, Xapi, John aka Edge, to CodeCrab, to all who contributed to the PSP hardware registers page, and to anyone else who contributed in one way or another by documenting or reversing things. That's the end. So thank you for listening.
That was amazing. I hope y'all will try using the media engine, or maybe contribute to it, or just enjoy the homebrews that use them. So right now we're going to get a presentation of a game we all know and love, which is Nazi Zombies Portable. And enjoy.
Hey everyone, I'm happy to be here again for another year talking about Nazi Zombies Portable. I missed last year. Oh no! But I'm here now to bore you. So in case you're unfamiliar, Nazi Zombies Portable is a project that started in 2009 and that I joined in 2016, which revolves around re-implementing the Call of Duty Zombies, spinning from World at War to Black Ops 2 somewhat, into a clean re-implementation inside of a Quake-based engine. Today I'm going to talk a little bit about some content updates that we've been working on, but mostly talking about some code unification efforts and also some quality assurance stuff that we've been doing, so automated tests and just good test habits in general. So just to get this out of the way first, I announced a big content update today, the day of the conference. I'm walking back on that a little bit. So a new map got pushed out today, and additionally 4 new game modes got pushed out specific to the FTE builds, which, if you're unfamiliar, is Windows, Linux, web, stuff like that. This was going to be on all platforms, but I have stayed up all night. It is the morning of the conference. It is now 2 a.m. trying to get some final technical issues worked out with memory and some random crashes I was seeing, but could not get there. It will show up last night. I need to sleep. I apologize. But due to that fact, I'm not going to really talk about those much today. So a bit of background about sort of where NZP was with quality assurance and sort of how things have been for quite a while. So NZP is a cross-platform project, in case the last slide didn't really give it away there. PlayStation Portable, Nintendo 3DS, Nintendo Switch, PlayStation Vita, desktop platforms, and also, as of yesterday, or 2 days ago, I guess, the TI Inspire CX2. It's up there in the top right. It ain't pretty, but it's there. And maintaining this stuff is a lot of work, right? Especially when it's an embedded system without much support from official parties, right? So testing kind of looks pretty barren. So about 9 months ago, I started working on how we could sort of solve this problem and how we could sort of bring everything together, which is what I'm going to get into here first. So the main problem here, sorry, can you tell I didn't rehearse this? We have a bunch of different source code repositories, or we did 9 months ago. We'll get to that, for all of our different platforms and sort of the back end for them, separate from the game code. But the problem with this was that it was a pain to work with. Whenever you'd have to make some sort of core change, like say I wanted to add some property, or I wanted to tweak the netcode a little bit, I would have to do that on 3-4 different repositories, mostly copy-paste work, but sometimes there wasn't, so there had to be a lot more thought. And there's some implementations for essentially the same task. So the solution here is a little obvious, right? We want to bring everything together in the one repository, one engine, which is what I've been working towards. We called that Vril, which is a reference to zombies. So here's how things looked before. We have our 4 pillars. We have our Quake Spasm Descendant platform, which is the PlayStation Vita, Nintendo Switch, GL Quake, which is the Nintendo 3DS, D-Quake Plus, which is the PlayStation Portable. These names descend from the people who originally brought up Quake on these platforms, and then they did all the hard work, we forked it off, added a bunch of missing features, and just sort of slapped, NZP compatibility in there. You can see how this created the problem described before. On the right, we have FTE, which is, our Windows, our Linux, our web-based platforms. So this is kind of its own thing, and is only here to sort of establish the fact that there is sort of a line that we don't cross. FTE is staying as it is. But where we're at right now is a 3-pillar approach, where we still have our Quake Spasm, our Vita, and our Switch builds. We have Vril brought up with the 3DS, the PSP, and the TI Inspire, along with, a half grayed out Wii there. There's a very unfortunate story about licensing issues with the toolchain, that we had this integrated, but we can't really build it or can't really maintain it, and the FTE build so far. So the overall goal, however, is to get everything that is an FTE consolidated in this Vril engine. So there's a lot of gains here with our organized code. For one, it's a lot easier for other parties to sort of dig into the weeds and want to explore it and, add changes and not be worried about, oh, what if this breaks this other platform, right? Or this is a little ambiguous. You don't really know the consequences. If everything is laid out and everything is cleaner, they'll have a better understanding of sort of what's going on. Another thing is that in general, it minimizes the number of forks in the road. Something that I've seen in this scene with cross-platform engines a lot is, it'll be cross-platform and it'll have the same feature set, but it'll fork in really strange directions, right? And it never feels coherent. It doesn't seem to follow a main path, where you have your branched off platform specific differences, and then you wind it back. You go back to your main path to keep things going. This is very, very important to me, and very, very important to making a project easier to port to. If you have just these little differences that you have to branch off and take care of your business and then go right back on the main path. And then, of course, if there's any critical bug fixes that you need to deploy, those are just kind of handled, I guess you could say, right? When it comes to automated testing, this new Vril engine, there's two things that we do. One is we turn on W error, which I hear a lot of people hate, but it has been very beneficial to us, especially when you're sort of to start smashing things together and then working your way into cleaning them up once they're all smashed together. It helps to see, like, oh, some types are misaligned, right? And if we didn't have this W error check, that would have caused issues later down the line, right? And then additionally, we have emulated on-device boot testing, as well as mean squared error tests as well. I'll get into that. So basically, the PPSSPP emulator with interpreter mode and software renderer is really, really great for catching visual regressions. I don't really see this being talked about much in here. There's a lot of stigma behind PPSSPP testing, which makes sense because there are stark differences, right? It's high-level emulation, but especially with visual stuff, they care a lot about their software renderer. If you notice differences with their software renderer compared to real hardware, you should reach out to them. They will fix it. I promise you, right? But it's super good for us, right? Because when you have that confidence that the software renderer is super good, we can use it and leverage it to catch visual regressions. On the right here, this is an example of PPSSPP reproducing a hardware visual bug with quantized textures. We use 4-bit per pixel CLUT4 textures. I believe Shapold will talk about that in a bit. We'll see. Maybe I'm wrong. PPSSPP caught this as well. So when we fix this bug, we haven't done it yet, but we could easily add this map or create a more simple map that invokes this bug again, add it to our testing pipeline, where we boot the game, boot all the levels. We compare screenshots taken from the emulator with these master screenshots that we have, which is the expected output. And then if this bug ever comes up again, right, we'll catch it and the build will fail, and we'll know, like, hey, there's something to fix, right? So just to sort of end this off a little bit, heed the warning, right? Easy to test code. This is just something in general. When it comes to games, at least from how I sort of think about what game development is, it's really hard to write testable code when everything is supposed to be interactive and there's so many things that can get in the way. NZP being as old as it is, and us not really caring as much as we do now. Sorry. our code was not very testable with unit tests in our game code. It took a lot of thought about the best ways to sort of get this done and to get this pushed through. And you really, really ought to think about this early on. End-to-end testing is good, like I described earlier with like visual bugs, but in terms of like catching gameplay features, unit tests are the way to go, and you should have like 10 million of them. But that being said, I'm going to hand it over to Shapold. Shapold is going to talk a little bit about some of his efforts with PSP platform optimization, a bit about the VFPU, and a bit about SEGU. But thanks for having me. Peace out.
Making real fly on PSP. We all love optimization. Hey, I'm Shapold. I'm a longtime Quake modder and a PSP tinkerer. In the past 2 years or so, I've done a fair amount of work on NZP and its real engine to make it run nicer on PSP. It's been a very satisfying optimizing challenge with many dimensions. In this talk, I will go through some aspects of it. What are we working with? NZP is running on the real engine, which is a modified Quake engine. Here's a screenshot. Which means we have a static light map BSP world with other smaller light map BSP submodels for doors and such. And also MDL models for more dynamic stuff. NZP supports modder-friendly 8-bit per pixel paletted texture, where every texture could have their custom 256 color palette. Compared to regular Quake, it also makes heavy use of MDL model props, so we have way more of these MDLs. There's a few performance challenges I'm talking about today. First of all, there's clipping. If you worked on PSP stuff, you know that polygons with vertices too far from the viewport just disappear completely. Quite frustrating when player has free camera control. Strategies for dealing with this is smaller subdivided polygons or clipping large polygons to view frustum. The PSP Quake engines have done the latter for all BSP geometry. It can get quite slow. Then there's texture cache. I mentioned 8-bit per pixel textures in the previous slide, and many of you might already know that's tricky to balance around. That's not all, as the way world and entities are drawn also make sure we can't draw everything using the same texture all at once. There's a lot of texture switching happening around. The MDL models use vertex animations with low precision of 80 bits per coordinate. They are formatted in a way where we kind of have to build the verts to send to the G on the fly. We cannot just store them all statically and use those. We take coordinates of the current frame and merge them with UVs shared between all animation frames. A lot of copying of data for each model drawn. And the fun part is that we're stretched very thin on RAM, so we have to be very mindful of that when choosing the strategies we use. Starting with a frustum clipper, there are some easy wins in here, very satisfying stuff. First of all, the clipping and how it works. As you can see in this diagram, we have the display in the middle, 2 polygons. The green triangle, it intersects the display edges, but not the virtual coordinate space. And the red one intersects both. So we can see, because the red one is outside the coordinate space, it's completely removed. So what we do in the clipper, we just clip the polygons to the viewport. That way we're safe. So, first of all, we do frustum culling in the engine as well, and this involves checking if any of the BSP nodes and their leaves are in the frustum before we start drawing them. We can easily modify this stage to detect if those nodes are completely within the frustum with very little overhead, so that they're not intersecting any of the frustum planes. In that case, we know that those nodes and their children, they do not need to be clipped. We don't even have to check it anymore. Then the crazier part. When we draw our light map geometry, It means we first draw the PSP Fulbright using regular textures. Then we draw it again using multiply blend mode and the light map texture. The engine used to do clipping separately for both passes, which is quite literally doing the exact same work twice. I can understand why, as it was not the easiest thing to change, but it's done now. Then for the last, there's the hacky part. As mentioned before, PSP calls polygons when a vertex goes far enough from the viewport, not when it just exits the viewport. What if we could use this when checking if a polygon needs clipping? The software clipping is all done in world space, which makes it a bit tricky. But the approach we came up was to use a different wider frustum for the cheaper clip checks. This makes sure that basically anything further from the camera never needs to be clipped, as it's always going to be within the wider frustum. This part required more work. How to optimize texture cache a little bit better. According to information online, PSP texture cache is about 8K, which means at 8 bits per pixel, you could only fit a 128 by 64 texture in it. Please let me know if you have more exact information. The obvious solution is to use more 4 bits per pixel texture. PSP games love to use this. However, when it comes to managing the assets and keeping the game mod friendly and portable, there aren't many good 16-color texture formats. The compromise we came up with was to convert 8 bits per pixel paletted textures to 4 bits per pixel paletted textures at a load time. It's not quite as heavy as it sounds. This way, users can still make their textures using the PCX format, which is very widely supported. We do this conversions for all map textures and most MDL textures. Of course, when we change palettes per texture, the natural evolution is to make sure we only change to each texture once per frame to avoid unnecessary changes and to keep the texture cache hot. For MDL entities, this is more straightforward. Just group them by their texture when rendering, helps a lot. For PSP models, it's a bit trickier because of the light map. The best we could do is identify when a PSP model is static and then render it with the world geometry for that frame, so that it doesn't require a separate pass. Each PSP is already drawn one texture at a time, so that part is then taken care of. Some NZP maps really like using many submodels, so this reduced a lot of extra texture changes. And then, of course, using 16 bits per pixel light maps as well instead of 32 bits per pixel saves both RAM and makes texture cache a little bit happier. The last part I wanted to talk about was optimizing our vertex animated models. These can use the CPU a lot. As mentioned before, the challenge here is that we can't just easily store everything ready to be sent to the GE. Models can have dozens of animation frames, and in order to have them ready, they need to have duplicate UVs for each frame. We do not have the RAM for this, unfortunately. One of the first things to try out was to reduce the operation we do per vertex. Vertices are using 8 bits per coordinate, which we previously then converted to floats for the GE. It's faster if we just copy the verts directly instead of converting. Thankfully, PSP supports 8 bits per coordinate verts using GU vertex 8-bit. We also identified that many of the models that are used are static props for decoration. If we notice that a model only ever uses one frame, animation frame, we can then reasonably store things in a GE-ready format without worrying about duplicate UV data. This is the optimal situation. Lastly, as we use vertex animation, we need to interpolate vertices between frames for smoother animation. Instead of doing this manually while creating our GE verts, we could utilize PSP's vertex morph feature. This means copying both verts we interpolate between for our draw array call and then use morph weight to control the interpolation. So, to wrap up this quick talk, our results are that our worst case performance went from around 15 frames per second to 30 frames per second in NDU, one of the heavier maps. Unfortunately, I don't have all the precise numbers of all the changes done. I did record those when doing these changes, but it's been time and I've lost some of those benchmarks. Some future work to make things even faster and lighter would be even faster clipping. I've identified that maybe we only need to clip polygons actually close to the near plane. It's something I need to actually experiment with to see if it works. Another huge thing would be to somehow use vertex colors instead of light maps. Then we would have to draw the world in only one pass instead of two. Of course, we'd have to subdivide the map geometry much more for this to not lose too much lighting detail. A partial approach would be to identify smaller polygons with less variety within their lighting and skip lighting for those only. Lastly, we store map words as floats, so maybe there's some wins to be had if we use smaller data for them, for example shorts. I believe the PSP data actually stores their verses as shorts already. Anyway, thank you for your interest. Huge thank you for the NZP team for keeping the project alive, kicking, and providing me an outlet for this kind of fun optimization work.
That was great. Thanks for continuing to maintain this awesome game. Give us a minute to start the next presentation, and thank you for listening so far.
Hello. Do you hear me? Okay, perfect. I will share my screen. I will disable the audio from YouTube and share the presentation that I have for you today. All right, thank you. Hi everyone. This is matching the compilation for PSP and how we crack the PSP compiler puzzle. Who am I? I am Luciano Ciccariello. Some of you knows me as Zainamo, and I'm currently a senior software engineer at Docker. My very first programming experience was actually on PSP back in 2008, where I released a homebrew called SmallHex, which is basically a hexadecimal editor for PSP, which is very inconvenient. You don't want to do that. It was just an experiment, but I'm grateful for the PSP community to have kickstart my career. In 2015, I had my first job as a developer, and in 2022, I started as a personal project, the Symphony of the Night Decompilation project, which will be the subject of this presentation today. So many of you probably heard about matching the compilation, but what it is and why is it hard? So matching the compilation is about creating the source code from a binary that we want to target, and this source code needs to compile back to the same binary, and every byte has to match. The producer's binary will be one-to-one with the software or the game we are targeting. And as you might guess, is more than just reverse engineering. In terms of complexity, try to imagine that it's like solving a 20,000 piece puzzle without the picture on the box. And just to kickstart a new decompilation project involves a serious amount of steps. For example, there is the compiler version hunt. That's the way how I call it. Imagine that you have a compiler that is version like 10.0. From 10.0 to 10.1, the outputs of the compiler will be completely different. And we had to search the exact compiler that the original developer used to produce the binary. Other than that, there is also about the programming language that the original developer used. For example, back on PlayStation Portable, a developer could use either C and C++, which they produce a different code gen. And you also had to find the compiler flags. The last challenge about a compiler is about the compiler optimizations, where a more aggressive compiler optimization will obfuscate the assembly outputs more compared to the original source code. So why did I decide to decompile Castlevania Symphony of the Night for PSP? Well, first of all, the game is good. It's a famous game, meaning that the pool of potential contributors is greater than other games. As today, our repository counts a total of 46 contributors. We started the compilation project using the PlayStation 1 build of the game, and that was compiled with the O2 optimizations, and that made the code quite tricky to match. Also, optimization means that multiple permutations of the same logic can match the same code. For example, if we take two statements of a C code and we swap them, the output will still match, will be still identical, because the compiler is doing some optimization under the hoods where it adjusts the statements to be more efficient. But what we wanted to have is to be authentic with the original source material. And that's where the PSP build of the game comes from. So the game Castlevania Dracula X Chronicles contains Castlevania Symphony of the Night, and interestingly, is not an emulated version of the PlayStation 1 game. It's actually a port. And a port is good news for us because it means that it is probably a recompiled version of the original source code. Upon investigation, we found that essentially what the original developers of Dracula X Chronicles did was to stop the PlayStation 1 SDK calls, so they will emulate the same original game behavior that would be present on PlayStation 1. And another reason why for introducing the PlayStation Portable version in our decomp is that the PSP uses the same MIPS architecture of the PlayStation 1, so existing contributors will feel right at home when reading assembly code. And surprise, the PlayStation Portable version of Symphony of the Night is actually compiled with no optimization, which is great news for us because that means that the compiled assembly mostly resembles the source code. Now, I mentioned the compiler hunts. So in details, what does that mean? So when we started to explore on how to get a one-to-one match from our existing codes, our existing decompiled PlayStation 1 code to PSP, we started to experiment with the different compilers that we assume that the original developers used. We tried at first with GCC, which is an open source compiler that most of you know, and the output was completely wrong. So you can see on the screenshot on the right side, you have a target and a current. The target is actually the assembly code that the final game has, and current, the column current, is what our code is currently producing. It's completely wrong again. So we started thinking more around this, like how back then developers were building games on PSP. We found that a company called Metroworks had an ID called Code Warriors for PSP, and that shipped with a compiler called Metroworks CC. And as you can see on the screenshot on the right, is much closer to our target, but it was still not enough. In fact, the version that we found initially was NWCC 1.1, and that was not issuing the right instruction calls for performing a cast of integers to the smaller types. I'm talking about SEB and SEH as instructions. So yeah, we were a bit on the corner. We started asking around on various forums or various Discord servers related to developments and the preservation. And we found a kind user who decided to remain anonymous, who agreed to upload the latest release version of Metroworks Code Warrior Studio for PSP. It was exactly version 1.2 and 1.3. The 1.3 version was actually contained in the compiler that allowed us to have our first match. As you can see on the screenshots, the left column and the right column are identical. So finding the compiler was not the final step, it was just the beginning, because we had to integrate the compiler in our build chain. And that proved to be very difficult. The reason is because the Metroworks Code Warrior IDE have a bunch of compilers and assemblers that were closed source and Windows only. and they were not as feature-rich as GCC. For example, they lack supports of inlining the assembly codes, or we were not able to use a list of undefined symbols in order to link our overlay for using external symbols. Luckily, one of the Symphony of the Night decomp contributors, MKST, developed a tool just for that. It's called MWGCC Gap, and it acts like a wrapper around MWCC, and it does, it's a bit of a pre-processor and a post-processor that allow us to add the missing features. One of them would be to inline the assembly codes, and the other one is for the object file that the MetaWorks compiler produces. This wrapper is able to fix the relocation table and allow us to reuse the same object on binutils from GNU, which is great news because binutils is quite feature complete nowadays, especially on the latest versions. And well, the great news about working in an open source environment is that now the same tool that was initially used for Symphony of the Night decomp is now used also for other decomp projects. Another user, another contributor of our project called Sozud, he recompiled the binutils 2.42 for Allegrex. And the amazing thing is that I realized that some of the patches of binutils, specifically to target Allegrex, were actually built by the PSP community. A few minutes ago, we saw that the community right now has binutils 2.44, so that probably will be in the next version we are going to use. Another project, open source project that we are using is called Weibo, which is a lightweight alternative to Wine for Linux and only targets CLI-only executables. So executing MetaWorks, these closed source compilers on Linux will be really fast. So I described about the build chain and the exploration process of finding a compiler, but how do we actually convert a binary code to C code? And again, a bunch of open source tools that were offered by the decompilation community. We start from Splat, which is an orchestrator that performs the disassembly process. And what I mean by that, imagine like a metadata file that contains a bunch of information to instruct Splat where the segments boundaries are located, or predefine a bunch of known symbols that we can, the disassembler can use. And what Splat will do is that will split the data and functions in separate files, and it will create a symbol list of undefined symbols and a linker script that we can all use to recompile all the disassembled code back into the original binary one-to-one. And Splat internally uses a very powerful disassembler called Spin Disasm, which is a matching MIPS disassembler. What I mean by matching MIPS disassembler, the assembly produced by this disassembler can be used by binutils to produce the same identical binary codes. For I'm talking about disassembling, but what about decompiling? For decompiling, we're essentially using the sheep of Theseus approach. That means that imagine like a boat made of wood. And we are going to replace every piece of wood from the boat with new ones, but it will still be the same boat, right? Now imagine this the process transporting to programming. Where the pieces of wood from the boats are actually assembly code that will be slowly being replaced with the decompiled C code. Other utilities that are very helpful to our quest are M2C, which is the tool that we are using to decompile our MIPS assembly code into C. And it is not pseudo C like the output from Ghidra or IDA Pro, but it's still potentially inaccurate code that we had to operate with in order to get a match. Other tools are ASM differ that allow us to iterate over code and checking if it matches. And one of the most amazing tools that everyone is using in the decomp community is called Decompiling, which is a collaborative decompilation tool. Imagine like GitHub or Pastebin, where you have a bunch of text where you can has the compilation and ASM different technologies, so you can work online from your browser and share the code you're decompiling with everyone else, and people can also help you. And I'm going to give you a demo of that right now. Let's do it. So I have this output here. You can see it's a bunch of assembly code that by itself it means nothing, and this is produced by Splat. I'm going to copy and paste it on Decomp.me, which is the tool I just mentioned. We select PlayStation Portable. We select the compiler that we found. I'm going to put the assembly code here. Context gives exactly what it says it does, gives some context on the compiler about a bunch of structures and signatures, so you can have a better understanding and more accurate outputs when the compiler will start to produce C code. I will show you directly. Yeah, this is the code that Mix2C produces. It doesn't compile. We are going to match this in live right now. So for example, here I can see the first thing we want to do is to remove the compilation errors. So we can see here line 18 and 19, there are a bunch of errors. I believe based on the knowledge that I have on the internals of Symphony of the Night, I know that this is calling the parent entity and is getting probably the position X value. And one error seems to be gone, and the second one will copy the position Y. Well, it's not working. Probably it's just weapon. Yeah, there you go. So this is right now what our C code is producing. This is the same concept that I showed previously in the screenshot. So on the left column, this is the code we are targeting, the assembly we are targeting. And on the right is our code. So let's work on this and let's try to get a match right now. One of the things that the compiler does is that it takes the parameter, it puts in a temporary variable, which is obviously not right. So we're going to replace this one with the actual parameter. And yeah, the output already starts to look better. So we get a 69% of completion. Nice. We get this one, put it here. We have a bunch of ends to 0FFF, so we probably can remove this, I believe. Yes, there are a bunch of casts that I believe they can be removed. This line is a bit weird, and I don't think that the compiler got it correct. I think this is Z priority -8. Yeah, we got a match. The rest of the code has some problems. For example, in line 19, we have this one that tries to do a conversion to a signed from an unsigned number. We see that our current gets unsigned half, but the target's actually a signed one. So we can try to do this as for signed. Yeah, there you go. Actually, what I'm going to do is that I'm going to take this one, right? I'm going to do a find and replace with from U16 to S16. Much better, 92%. All right, let's continue. So I can see he is taking a variable and is doing +1. I think this can be simplified as just plus. Yeah, there you go. And we have a bunch of orders on the bottom. So you can do minus equal to 2. This is +8, I believe, plus equal to 8. Wow, okay, 99.92%. So the last piece that we have to match is a reg swap. So it is expecting a 80 registry, but we have F1, B1. This is line 26. And well, I know for certain that you had to remove the equal sign from here and essentially put a 10 here. And there you go. In a few minutes, we have a function that we just decompiling live right now that matches the assembly that we are trying to target. Returning back to the slides. So how decompiling the PSP build benefits us? So first of all, cross-compiling the matching code on different platforms and using different compilers allow us to be more accurate. For example, take these if statements. Logically, they are the same, but their code gen is completely different. Also, the PlayStation Portable build allow us to better determine where the source boundary is. And what we found is that the PSP source the PSP game was compiled with a different order of function compared to the PlayStation 1. Therefore, probably was like compiled, the C files were compiled in alphabetic order. So that gave us a better understanding where actually the C code boundaries were located. And also we got other hints, like, for example, like if a global variable was actually a part of the structure node. One good thing is that we can actually take a function that is decompiled and it is matching with the PlayStation 1, the PlayStation Portable at the same time. It can just like copy and paste it to the Symphony of the Night for Saturn, and it will just match because the code is so accurate that we can easily port it to the different releases of the game. And another amazing things about modding. For example, we were able to port PlayStation Portable exclusive content from Castlevania Symphony of the Night on PlayStation 1. This one is Maria, which is an exclusive character from PlayStation Portable, and we literally released a mod yesterday that does that exactly that. So I talk a lot about how this is benefiting us, but how can it benefit the PlayStation Portable community? Well, first of all, I think that the compilation will allow you to research for undocumented feature on unused mechanics of both softwares and video games. Once you get the source code, you can do practically everything. You can optimize it, you can expand it, recompile it, or even port it to different platforms. You can create gameplay mods like the one I just showed you before, or making advanced mods or patches that rely on code relocation. And I think it would be pretty cool to see a PSP firmware decomp. I'm not gonna say here how you can use it, but one of my ideas that I have in mind is that it can fuel a better, accurate, high-level emulation. And I don't think I have time for the questions because I'm overdue the 20 minutes. But if you do, please drop me a message on Discord. I will be happy to reply. Thank you very much.
Well, thanks a lot for that. That was a great presentation. Hopefully the next person will come into our Discord. So give us a couple minutes, then we'll come back to you. Okay. Then I will tell you more about SDL like I promised at the beginning. So SDL is a library for abstracting system-specific details. You can do all kinds of things with it. We have 2D graphics, controls, audio, file system stuff. You can even manage OpenGL. I will show you on that. So one cool thing that SDL offers is that it allows you to avoid doing the setup for your main. So normally what you would do is write this code just to have an empty main on the PSP, because you want your game to be able to quit using the home button, and you need this PSP module info, otherwise it won't launch. And in SDL you can just do this. You can import SDL main and define your main. This is similar to SDL2. Like in SDL2 you would link to an SDL main library instead of including it, but it's basically the same. But SDL3 has a new system which allows you to not have a main at all and to not have to manage your game loop, which is amazing. So you would define this SDL main use callbacks at the top and make sure to include SDL main. And then you can use the app init function to initialize your app. Then we have the app iterate, which runs in a loop. Then SDL app event to handle individual events that come in. And then we have SDL app quit for just when the game ends, just for cleanup mostly. So I'll show you each of these functions. I'll start with SDL app init. What is cool here is that if something fails, we can just return SDL app failure, and the app will run the SDL app quit and be done. And we have this app state struct. So for each applications that uses this system, you will want to create this, and it can have anything in it you want, but you'll probably want the renderer and the window in there. Depends a bit. Renderer is for if you want to draw 2D things. So here in this example, I use SDL create window and render, and then I write that to this app state variable. First we allocate some memory for it, of course, and then at the end we return SDL app continue to tell the app that it worked out, and we can start the loop. So then when the event comes in, this is a very basic example. So we want to be able to use the gamepad API of SDL. So we use SDL open gamepad whenever a gamepad is added. And here's a very basic example with, so if a gamepad button is pressed and it is the button start, then we just close the app. Like app success is like we finish the app successfully. Also, if an SDL quit event happens, we do the same, which is if you press the home button and you close it, or on your PC you click the cross button at the top, and this also return at the end you return SDL app continue. And then we have the app iterate. Here you have an example of how you can get the app state in your function, and then you can also use the values from it. This is a very basic example to draw a little block on the screen and set the background color to white, and then just show it. And then we have the SDL app quit, in which you run SDL quit and you clean up all the things you used, which is always good to do. And then of course we have the CMake file. Here in this case there's something PSP specific, which is that we want to create an eboot file, and this would only run for the PSP. And if you were to compile it on Linux or Windows, then this isn't used. And linking to SDL is very easy. You just tell target link libraries and you select SDL3 here. And for CMake, to build it, you use PSP CMake, and then you just run make. And then we have something like this, which is a good beginning for your game. But why are we doing this? Like, why do we need SDL3? So here's a little example. So on the left we have the PSP specific code for initializing being able to draw 2D shapes to the screen. And on the right we have the same thing, but for SDL3, which is a lot less. And what you have to keep in mind is the right works on any platform, the left works on PSP. And we have the same thing when we just want to draw a little block on the screen. Like with the PSP specific thing, you would have to create a struct for vertex, and then you have to create them and draw them. Like this example is not so different, but you can see that these things, they do add up. And this is the main thing why you would want to use SDL3. Namely, this is an example of a game using SDL2. Yeah, I made it, it's called Ocean Pop. If you want to check it out, go for it. But I have it working on my Linux machine, I have it working on the PSP, I even have it on the Wii and the PlayStation Vita, and the code is all the same, and the build script is even the same. And then we have some additional features in SDL, like we can load images and sounds, and that is easy, and you can just load your texture and then render it. And there's also some helper libraries. We have SDL image to load PNGs and JPEGs, and then we have SDL DTF to load text from a font file, and then you can render your own text. Right now, SDL Mixer, so SDL Mixer is a tool to load different audio files and play, like mix different sounds. And this is not yet done for SDL3, but you might not necessarily need it because WAV files can be loaded. But if you really need SDL Mixer, then you're better off using SDL2 for now. Just so you're aware of that. And then I wanted to still show how you would do OpenGL with SDL, because I think, so from what I've seen, SDL is not used very much for OpenGL software, but I think it's great, and I think more people should use it, so I'm just gonna show you. So here, what you'd have to do is you have to include SDL OpenGL.h, and you have to have a GL context in your app state. And starting this context, it's a little bit different than the other example I had for the initialization, because here we just create the window and we don't create a render, instead we create a context. And once you have the context, you can actually do OpenGL things. And here's a very basic example of an app iterate which could do some SDL, some OpenGL stuff. One thing to note is we have OpenGL 1.2. We have some features from OpenGL 2 and OpenGL ES. I think we have a couple versions implemented as well. So you can't do shaders, but you can draw things. And here I just show, like, we clear the buffer. Here you would put your code to draw something, and then these two commands will reset the screen again. And that's all I want to say for now. I hope you have a lot of fun with SDL3, and thank you for listening. So next up we have Andrew with his presentation on Zombie Crisis Director's Cut.
Hey, sorry about that. I ran into a issue where I must have done the time conversion incorrectly, and are you able to see my screen? I wasn't able to connect. Hmm. Share screen. Go live. All right. In 2008, Zombie Crisis began as an experimental game jam of sorts, with some self-imposed limitations and unique challenges. Jeffrey Van Dijk and myself wanted to see if we could think up, develop, and release a completely standalone mini-mod using our game of choice, Duke Nukem 3D, in a very short time frame. The entire project, from start to finish, had about a 5-month incubation period from the beginning to the end of development. We found that after removing all of the original art, music, sound, and other copyrighted assets, it made development much smoother, as it allowed us to a lot of additional freedom and flexibility during development. Despite being built on the foundation of Duke 3D, Zombie Crisis was intended to mimic the much earlier first-person shooters like Wolfenstein 3D, Blakestone, and Rise of the Triad. And to that end, I do think we had succeeded. But it also pulled the curtain back on a lot of missed potential and opportunities that our small development scope didn't explore. To my surprise, Zombie Crisis ended up being somewhat popular upon release for both the Windows and PSP crowds. Over the last 17 years, I've been paying close attention to just about all the feedback that it's received from ModDB, from YouTube, from various homebrew websites. I wanted to make sure that this year I decided to put all of that feedback to good use and give people what they wanted and kind of create a substantial quality of life update in the form of a director's cut that includes the requested new weapons, enemies, features, remastered levels, and more, directly inspired from the community feedback over the years. The core gameplay loop is still the same. It's still got the same roots in those linear, simple corridor shooters. It just now has a significant amount of added variety, making the experience much more varied and much less a monotonous grind. That included making sure to rebalance the project to prevent player soft lock, to ensure balanced gameplay for all difficulty levels, and just to make sure that it's fun first and foremost. With that in mind, I've also forked and designed a unique balancing specifically for the PSP to provide the best experience for the platform. While the Director's Cut content remains the same across all the builds, the PSP and Windows versions do have their own unique health, ammo, damage, item drop, and hit point values to make the most out of each platform and provide the best experience. Basically, the Windows experience with keyboard and mouse isn't quite it is more accurate than you would on a controller attached to a handheld, so I wanted to make sure that I kept the experience fun no matter what platform it was on. The goal of the game is still to defeat all the enemies and exit the level, but you now have a lot more variety with the weapons, with fighting new enemies and just making for a much more varied overall experience. Speaking specifically about the PSP, it's been updated with new technology thanks to the amazing efforts of Sergei Crowbar Galishko. Unlike the original PSP release, you can now save, load, customize your controls, more, without any crashes or issues. The original port that we had used had a lot of audio issues and a lot of crashes, but this new technology is a complete game changer, and it's one of the reasons that inspired me to continue and create the PSP release. The levels will be from the original release are also being updated and completely remixed and remastered, adding detail, expanding and updating them with new weapons and enemies, and just kind of refreshing it with new areas, paths, and more to take advantage of the update while keeping things familiar. Zombie Crisis is planned for a release date later this summer for Windows, PSP, and PS Vita through Adrenaline on custom firmware. And I'll take you through the first level here real quick. As you can see, the levels are kind of maze-like. That's the influence from the Wolfenstein 3D and early FPS markets. One of the goals was to achieve over-the-top Dead Alive, Brain Dead, Evil Dead 2 type of over-the-top experience. Basically, we wanted the over-the-top violence to be kind of comical, and kind of usurp the simple level design that's in the game. If I can survive here. But it comes with 6 levels. They're still being worked on. This one has been updated, but it's not the remastered one. But we do have someone now working on level and world creation, so we expect that to be done sometime this summer and soon. But overall, it's just been a fun hobby project, and I just love giving the PSP some love. And I thank you all very much for your time and for allowing me to make this presentation. It's most appreciative. I hope you enjoy the project once it releases, and as always, if you have any feedback, questions, or general ideas, don't hesitate to DM me, and we'll deep dive and kind of hash things out.
Cool, thank you very much. That was a great presentation.
Thank you. My pleasure. I appreciate it, and I thank you for the invitation. It's been fun.
So I'm looking forward to playing this game. I'll set up the next presentation. If you give me a second.
Hello and welcome to this presentation of PSP HDC25 for the Liphoop Homebrew engine and how you can use that engine for your PSP project. So today we are going to focus on a project I did on the PSP with the engine, which is named Something is Going Wrong for I think 2022 Game Jam. So you can find the project on this link on each, and we're gonna see, so all of it were developed on Leap engine, which was named at that time Gen 7 engine. We can see some screen from the PSP from PPSSPP from the PSP emulator, and we can see a screen on the real PSP, because actually I recommend for any project, any game, anything developed with Liphoop to be tested on real hardware, because it's designed for real hardware, and actually emulators may introduce a lot of bugs that are unwanted. So before to continue forward, I'm gonna show you also the website for Liphoop engine, when you can actually download the editor, which can work on Windows and Linux. Join the Lip Engine community on Discord, and see also all the other things that are related to the engine, such as what the platforms that are currently supported: Windows, Linux, the Switch, the Wii, the GameCube, and of course the PSP. And there is also the documentation that you can access on that link, and that will show a lot of tips, the glossary of all functions, some sample tutorials, and how you can create your own plugins. As I said, let's switch to the editor now. I'm gonna launch it. And now we will open directly the PSP Game Jam project, which is actually present too on your setup, on your installation. You will find it under projects, and it's gonna be named Project Game Jam PSP HDC22. There's only one scene, but it contains everything, and actually there is sub-scenes under in the code that I'm gonna show you right now. So here we go. There is the project, the Game Jam project. Let's zoom a bit on the code editor. So first, like, we have some sample configurations such as the scene step. So this actually to set up which scene the project is gonna start at, the camera configuration. The whole project is 3D also, it's very important. So on File Explorer 2 we can see all the assets, so mostly textures and 3D models that are used. I'm not gonna dive deep in the code, but I encourage you, if you want to see how it works, how the demo works, to go through the code and see how it has been developed, what are the methods that are used, and yeah, everything around it. Anyway, let's preview and see if everything works properly. And yeah, here we go. We have like the preview of the first scene. It's so here, like, I put scene step at -2, and the scenes are managed here. So yeah, this is a scene step on update, and at start it's gonna configure the title. So the title, even the title and everything, is a 3D model. We have also other sample functions. For example, we have a function to orbit around the point with some like trigonometry calculations to know about it, and many things about the terrain, the character control, everything. So yeah, as said enough, you can dive deep into it and see how it works. We also had the hierarchy that shows like all the objects that I created on the scene. So for example, here we have some primitives, we have some textures, we have 3 models, and we have the scene object that actually embed the assets that have been loaded by the scene. In the File Explorer, we have like all the assets. Engine logs is not gonna be used, and console logs, this can be useful, however, because yeah, if sometimes you have projects in your logic, in the game's logic or your app logic or whatever, you can see it displayed here, and it can help you dive deep into what compilation. Okay. We also, there is 3 modes for rendering. So for example, right now is on shaded rendering, and I think it's configured 2 in the code. Oh, it doesn't look so. Let's try and see then. I'm gonna put wireframe and then I'm gonna preview again. That way it doesn't display anything. And then if I preview again with lighting, yeah, for example here we have the lighting that has been loaded, but actually we don't really need lighting. That's just bare lighting. Like, we prefer the shaded preview. So now that we have our shaded preview, we can just try to play the game as it is. So to do that, we just go through play scene, and here we go. Let's start the adventure. Okay, I can move around. It's nice. I can orbit too. Okay, let's continue. Oh, nice, a new scene. Okay. So we have to catch the ghost. Where is it? Oh, it's gone. Nice. Got it quick. Okay. So this is just to try around and then see what it looks like. And now we can do the same on PSP as well. So the game is already built. I have already built it before the video, but you can always build it again by going through here, by selecting PSP, waiting a bit, and then it's gonna be in the release folder where you extracted the editor. And let's run the game. Okay, start the adventure. So everything is working well so far. We can move around the scene. Can meet the camel. Oh, nice. Okay, and we can continue. So now let's get back to the engine. So we have built our application and everything. So about the script too, so it's based on Python, and there's also several plugins, several modules you can import too, and they are all listed on the documentation. That's why I highly recommend to take a look at the recommendation. Like, there is also several script example. You can also create 2D projects. So for example, this is one of the 2D projects where there is a sample on transitions and everything. For the method, they are all listed here with specific object. And I can show you also quick the Visual Script Editor. So right now it's disabled because this project is completely developed with code, and it has to be picked at project creation, because every time like you do an edit here, it's going to overwrite your editor. So let's overwrite. And yeah, as you can see, if you want to create your project with visual programming, here is a visual editor that you can use. You can also like import, like let's say you have a 3D model, you can import it with create asset, model, file name, and do everything kinda like with the code editor, but just gonna be about blocks, and you have all the other basic structures that can be used for it. So I guess that's all for this tour of today of Liphoop Engine. I hope you liked it, and yeah, I encourage you to go deep into that project, to create your own stuff for the PSP, and I wish you a lot of luck. Thank you, and have a good day ahead.
It's great to see people supporting the PlayStation Portable with their custom game engines and tools. Now for the next presentation, we will be looking at a game called Neighbours from Hell. intro and enjoy.
Hello guys, I'm Denshon. I want to present you my new homebrew project for PSP called Neighbours from Hell. My project is powered by Lua Player by Yulia team and is written in Lua programming language, while original Neighbours from Hell game uses G framework with C++ programming language. And because there is no source code of original game, I decided to rewrite it from scratch. As an engine, I chose Lua Player by Yulia team, or Hell PUT, because it has good performance and advanced image draft parameters, such as position, size, color, source position, source size, rotation, alpha, and align mode. These parameters are enough to create an advanced game. I pay a lot of attention to details to make my PSP version be at least 99% like the original game. Also, my project will have a GitHub page with source code, and that means that anyone who can code can make mods. Mods for my PSP version won't be only graphical. Because my project is open source, you can add anything you want. You can change any mechanic or add a new one. The most important is understanding the basic rules. They are written in code as a comments. Graphics in my PSP version have lower resolution than original. Game objects like house, woody, neighbor is at 50% of original resolution, and the user interface is at 75% of original resolution. Why 75%? The screen width of the original game is 640 pixels, and the screen width of PSP is at 480 pixels, and the 75% of 640 equals 480. Animation system in my project is very similar to the original. This is a start animation of Woody, but I can easily modify it. I just need to modify frames names. Result. Also, I can change sounds. Also, I can easily modify doors. And that's all what I wanted to show you. If you want, you can leave your question here, and I will make a video for my YouTube channel. There I'll answer your questions. Goodbye.
Another great presentation, and we have two more coming up. One about very short one about Minecraft story mode being developed for the PSP by Entity, by the way. Enjoy.
Hey, I'm Eddie Basway and I'm developer of Minecraft Story Mode Season 1 for PSP. I got my first PSP in summer 2024, started porting in December 2024. This port is based on the Netflix interactive version of Minecraft Story Mode. It runs on PSP hardware, uses the Lua Player Uta engine by the Yulia team. So, how do choices actually work in this port? Let me explain. The choice system in this PSP port is simple. Each scene consists of a PNG video, a trimmed cutscene that plays first, a PNG image, the last frame of the video with buttons and text overlaid, shown immediately after the video for a smooth transition, a Lua script that plays the PNG video and displays the PNG image, waits for player input, and then loads the next scene. Here's what the example code and folder structure look like. Okay, time to move on to something a bit different. I download videos using the Cobalt, then open them in Xvideo PSP5, a simple but powerful video converter, to trim the footage right up to the moment when the choice starts and convert it. After trimming, I extract the last frame as a PNG image and edit it in Photoshop to add the choice buttons. Finally, I export the trimmed video to the PNG format and set everything up with Lua scripts. Here's an interesting fact about this port. The videos for the episode menu are recorded on my Steam Deck OLED. For now, episodes 1 and 2 are ready and available on the Minecraft Story Mode Portable GitHub page. PSP still rocks as a portable platform for creative projects. Just dive in and make your own cool stuff. Thanks!
Another great presentation by the community. Right now we're setting up for the next presentation, which is about Arc 4 by Acid Snake. This could take us like a minute or two. Please be patient.
Yeah, the microphone works. It's the camera I'm having issues with. Hold on a second. Supposed to be working on the. Why isn't it not working here? Excuse me. Oh, okay. Okay. Now you can see the video. Okay, we can start whenever you want. We're on. Okay, so like last year, this presentation is gonna be a test drive around the Arc 4 custom firmware. I'm gonna be showing some of its features, um, live testing it, and it's pretty much gonna be a continuation from last year. We're not gonna talk about code. We're not gonna talk about any of that. Next year, I will start going speaking more about the code and showing the code and everything. But this year, I want to make this presentation to be more focused on the end user, what the end user is gonna see when he installs Arc, what the features it has for the end user, etc. So right now I'm on the XMB, the original Sony menu, and you can see it's a bit different because I have the CXMB plugin installed, so I can use custom themes. Right, so there's a lot of custom themes made by the community. Some of them are beautiful. So yeah, it's another one of those pieces of software that enhances the flavor of the PSP. It's not built into Arc. This is a plugin. Let me emphasize that. Now, plugins can be managed on the XMB itself, as opposed to classic custom firmwares where you would have to go to recovery menu. With Arc, you can manage plugins and custom firmware settings right from the XMB. So I'm gonna show you some of the plugins I have installed. First one is Leda, the legacy loader created by Dark Alex, which adds compatibility with Legacy 1.50 Homebrew. It's really high compatibility, and the great thing about Leda is that it works across all models, including the PS Vita. So it gives models that are completely incompatible with the 1.50 kernel. You can run 1.50 Homebrew using this plugin, and it has a really high degree of compatibility. Not perfect, but a really high degree. And like I said, it works on the PS Vita too. Because I have this isn't a plugin. This is more like a something you have to configure if you want to debug using PSP Link on PS1 games. Then I have PSP Link, It's a debugging tool, basically. Category light. I don't have it enabled, but if when you enable it, it allows you to categorize all your games in the XMB. I actually have them all categorized, but I don't have the plugin enabled, so most of the games, like most of my ISOs, aren't going to show up here. Okay, CXMB, I've already talked about this one. Day Viewer, a very famous plugin created by Total Noob, which is nowadays known as the Flow. It's the one that lets you see this information right on top of the top right corner of the screen, and you can change the format and change everything about it. It's pretty cool. There's a game version, but I only have the XMB version installed. Macrofire can help you fine tune the dead zone of your joystick. It can also help you allow you to remap buttons. I have it disabled because I installed it back when the joystick of another one of my PSPs was drifting, and it helped. But I changed the joystick, so I disabled the plugin. The classic LCS and VCS cheat devices, which I have disabled because they are classic and they are no longer maintained, and they have a lot of bugs and issues, especially with later firmwares. I only really use them because they are very exquisite. So if the custom firmware fucks something up, excuse me for my wording, um, I can know by using one of these because they are very sensitive and they crash very easily. But then there's the remaster version, which is a lot better. I recommend it. It has a lot of newer mods, like the ability to swim in Liberty City Stories. I love it. That feature was actually my request, and I love how it ended up being. So I'm promoting it right now, right here. CW cheat. This one is for cheating. It's another cheat device, but more generic cheat device. It works for every other game. The PS1 version, and these are just lines to disable CW cheat when running GTA games because um, I don't want to have cheat device remastered and CW cheat running at the same time in GTA games. I don't need this running in a GTA game when I have this one. Just another feature that Arc has, it lets you enable plugins per game. The CW Cheat Remaster plugin is only enabled on the GTA games. You can see the game ID. But you can also disable plugins per game. So I have the CW Cheat disable on those games. The disabled configuration must appear after the enable configuration. That's the only quirk, but it works perfectly. It works both with game ID and also with path when we're speaking of homebrew, because homebrews don't have a specific game ID. They reuse some random game ID from a game, from an actual retail game. I don't know why they did that. They should have just made it up, but whatever. PRX shot. This one allows you to take screenshots. Pops loader. This one is rarely used nowadays because a lot of problematic games, PS1 games, have been fixed via configurations. But there's always some pesky games like Destruction Derby 2 that won't work with modern PS1 emulator. And the PS1 emulator was created by Sony. We don't have any source code or any easy way to modify it. We can only configure it. We very recently learned how to configure it. We didn't even know it was possible to have custom configuration, but it is possible. But there's always some game that only wanna work with a very old version of Pops, the official PS1 emulator. So this allows you to boot it. CDDA enabler can be used in conjunction with Pops Loader to enable CDDA, CD Direct Audio, which was disabled by Sony on a very specific firmware version. If you're using the standard ARC binary, the standard ARC without Pops Loader, you don't need CDDA enabler because it's built into the ARC popcorn module, which is the one that patches PS1 emulator. But when you use Pops Loader, that ARC module gets replaced by a custom one from Pops Loader that doesn't have CDDA patches, so you have to combine it with this plugin. Um, Pro Online, I haven't really used it much, but I know it has a lot of problems. It works, but it has a lot of problems. Uh, not necessarily related to ARC. It has a lot of problems everywhere. So CFE, this one is awesome. I like it a lot. I don't know why I have it disabled. It enhances the custom firmware experience. And well, a lot more. I'm not gonna go into all of them because they're not part of ARC. I was just showing the different ways to configure plugins. And now we're gonna go to the custom firmware settings. So these settings affect the entire custom firmware or the XMB. So basically, anything that's gonna modify the behavior of the official Sony firmware. All right. So first one is USB charge. This one is always by default USB charge when you enable it here in system settings. There's a setting for that. USB charge. This one only affects when you're in USB mode, right? So when you're connected and you put the console in USB mode, so you can't really do anything else with the console. You cannot play games. You have to wait. You have to wait for it to charge, and then you can play games. With this feature, you can turn on USB mode everywhere, so you can charge everywhere and anywhere. Now, this feature very recently, we found out that it had an incompatibility with the the camera add-on. And the reason for that is because when you enable USB charge and you try to use the camera, it's just not going to work. The camera needs um, it creates a problem. So we fixed it by automatically detecting when you're loading the camera module, when your camera is starting up. We disable USB charge automatically, so this feature is no longer bugged. But classic custom firmwares that have this feature, like Pro and ME, they are bugged. So if in Pro and ME, if you have this feature enabled and you try to use the camera, you're gonna get a crash. Like your console's gonna crash and shut down. All right, CPU clock in game and in XMB. In previous ARC versions, probably the last time I showed it, these three settings were actually outside. So you had overclock and you had the other ones right here. But I noticed that you can only really change clock settings in PSP games and the XMB. You cannot change it in PS1 games, mostly because in PS1 games it uses the maximum clock speed. If you could actually change it and you change it to something else, it's gonna go slower. The PSP already overclocks to 333. I call it overclock because it's easier for users to understand what is happening. Um, but really, it's basically the max clock setting that the PSP can go without having hardware issues. And then we have WPA2 support. This one was very new and it came out of nowhere. So this developer, who's probably an expert in networking, he just came out of nowhere. He dropped a PRX plugin that became ultra popular. He also gave us the source code. And what we did was just incorporate that source code into the custom firmware so it's built into it. Because we thought it was a very important feature. It revived the PSP networking capabilities. It has its quirks and it's some bugs, but it works pretty damn well. And it's much better than whatever we had before. So it's enabled by default. If you download the latest ARC 4, it's going to be enabled by default. All right, Audible Launcher. It just every time you try to boot into the XMB, it'll redirect to the custom launcher. This one's mostly useful when the XMB is broken for whatever reason. One of the reasons could be, for example, PSP Go with a broken internal memory. The XMB can have issues loading. It can take it a while to load. It can have a lot of different issues. So there's some scenarios where the XMB not be used. So thankfully we have a custom launcher that is it's pretty damn good as an alternative. Right, the use extra memory setting. This one became a little bit controversial last time that we changed it because it used to be an on-off feature. Now it's auto and forced. So why auto? Why is there no off setting? Well, basically because there are homebrews, very specific homebrews, most of them emulators, that they have a flag in their param.sfo file. They have a flag that specifies that the homebrew will use the extra memory. So in that case, the custom firmware has to enforce extra memory because otherwise, if the homebrew tries to access extra memory without it being enforced, otherwise it could have potential crashes with other homebrew, other parts of the firmware that tries to use the extra RAM too. For example, the UMD cache setting uses extra RAM, and if both the homebrew and the UMD cache are using the same RAM, they can cause a crash. So if we drain the extra RAM and give it all to the user, there's not going to be an issue. So the reason it's called auto is because on some occasions, for the most part, extra memory is always disabled. You cannot enable it in the XMB because it'll cause a crash in the XMB. You cannot enable it in PS1 games because it'll cause a crash in PS1 games. You can only really enable it in PSP games and PSP Homebrew, PSP apps. And some of those homebrew will ask the custom firmware to enable it for them. So that's why it's called auto. Very rarely, some homebrew will have this setting enabled. So for me, it was better to just say auto rather than say no and then or off and then why it's extra RAM being enabled if I have it enough. Well, because you're running a homebrew that requires it. Memory stick speed up. This is an old setting from the M33 times. It was very useful back then, especially with compressed ISO files. Nowadays, it could still be useful, but you're not gonna see the difference as big as back then. First of all, because compressed ISO drivers with Inferno 2, they're extremely optimized. So they don't need any speed up. The speed up is already baked into the Inferno 2 ISO driver. But some homebrew, especially things like the XMB when scanning games, things like the custom launcher with scanning games, and many homebrew that have to read small amounts of bytes sequentially in a file. A lot of small IO calls is going to be worse than one big IO call. So this setting basically is going to attempt to it's going to have a cache that's going to attempt to minimize the amount of IO calls. So it does have some speed up in very specific areas. Like I said, not as noticeable as back then, back in the M33 days, but certainly it could get noticeable, especially when you're in the XMB scanning games or the custom launcher scanning games, etc. Inferno cache is basically the equivalent of UMD cache, but for ISO instead of UMD. It uses the extra RAM that PSP has. On the 1K, it uses a small cache on kernel memory, but on the other models, it uses the extra RAM. And basically, it can help, but again, like memory stick speed up. Um, these settings no longer give you the advantage that they used to give for two main reasons. First is because Inferno is a lot more optimized than the older drivers, Inferno 1, M33, ME, etc. And secondly, because we now have, show you here, we have high speed SD cards now, as opposed to the extremely slow speed memory sticks of the past. Again, it doesn't hurt to have them enabled, but it's not, you're not gonna see a big of a difference like it used to be. I so skip Sony logos. This one allows you to skip the logo that appears when you turn on the console, and or the one that appears when you boot up a game. Hide pick 0 and pick 1. It'll hide basically when you go to a game. Pick 0 and pick 1 is going to be the background pictures. For example, on a PS1 game, there's the background picture is going to be pick 1, and this smaller picture that's on top of it is going to be pick 0. And you can disable one or you can disable both of them. That's mostly helps in navigating the XMB faster because you're forcing it to read less stuff. Let's see. Okay. Hide MAC address. This one's a no-brainer. When you go to the system settings and you go to system information, the MAC address is going to be replaced by the model number. Let's see. Right, hide DLC. There's some games that have DLC, and when you have the DLC installed, they both appear. Both the DLC and the game appear in your list of games. So the hide DLC setting is gonna, like the name implies, is gonna hide that DLC from the XMB, so that your XMB is not cluttered with a lot of useless icons. Turn off LEDs. This one will turn off the LEDs, both the power LED, the Wi-Fi LED, and the memory stick LED. They will all turn off. The reasoning is pretty simple: to save battery. Disable UMD drive. This one is mostly if you have a broken UMD drive that's problematic. This one can help you at least bypass the problems. Disable analog stick. This is a very quick solution, so to speak, when you have a drifting analog. I mean, the better solution would be to replace it, or if you're looking for a software solution, Macrofire, like I explained earlier, it can help you fine tune the dead zone. But yeah, this is a quick band-aid, so to speak. That's built into the custom firmware. UMD region. Okay, so this one, well, this model specifically doesn't have a UMD drive. It has a custom battery mod. But yeah, I already showed this feature in the last PSP HDC. Basically, a lot of UMD movies, not games, but movies, they are locked to specific regions. So if you try to play, for example, in my case, I'm in Europe, so all my consoles are European. If I buy an American UMD, chances are it's gonna be region free and I will be able to play it. But there's chances that it will be region locked and I won't be able to play it. With this setting, you can change the region of your UMD drive on the fly. It's instant. As soon as you hit on one of these, it's gonna do whatever it has to do, and it's gonna change the UMD region on the fly right now. I mean, if I had a UMD, I would be able to I would be able to show, but I mean, I do have a UMD, but I already did this last PSP HDC, so I'm not gonna do it again. I wasn't prepared to show this feature again because I already showed it. VSH region is not the same as UMD region. VSH region is it's more visual. Basically, the region that your XMB thinks it's using. This PSP is basically, I believe it. I don't remember what region it had, but I do remember that the extra section does not have a. I mean, it doesn't have an extra section. So I had to change the region to Europe so I can have an extra section and have these icons here. If you don't have an extra section, these icons are gonna be in the game section. Okay. And finally, QA flags, which all it does is enable the debug settings here, which don't do anything at all, basically. But it's cool to have it. It just looks cool to have this feature enabled. And let's see. Okay, so the VSH menu is another thing that's been completely revamped when you compare it to classic custom firmware. We allow you to change basically anything. The background, the foreground, you can pick your color combination. And it really doesn't have much settings. You can change the USB device to access other like Flash Zero, the UMD. Notice how as soon as I select Flash Zero, the USB read-only settings gets enabled. You see that? That's a protection that ARC does. Because if you mount Flash Zero and you touch things without knowing, you're gonna get a brick. So let's say your kid is playing around with your PSP. It's pretty easy for him to mess with this sort of settings. So we have made this protection. We try to basically everything that could be advanced is sort of either we try to do it automatically, like not allow user input because user input could be faulty, or we try to enforce some sort of protection to prevent unwanted tampering or to prevent someone who doesn't know from touching things without knowing. All right, so let me click something. There we go. You can change the font too. And we have a lot of different fonts built in. You can change the menu design back to the classic VSH menu style. I don't like it. It looks ugly, but well, for nostalgia, it's there. You can swap the X circle buttons. You can import classic plugins from Pro and ME into the ARC format. Reset ARC settings, both custom firmware settings and also menu settings like VSH menu and custom launcher settings. Everything's reset. Okay, that's for VSH menu. VSH menu is very, very simple. I've always been very, I'm not gonna say hate, but very against VSH menu for a simple fact, and it's because it's pretty damn old. It doesn't look very good. The code looked even worse. So we did a lot of maintenance, and now it's much better. But we try to avoid VSH menu as much as possible, and we just have it like this mini hub where you can go to recovery menu, shut down device, suspend, reset, etc., and not much more. All right. So in terms of gaming, which is what most people's gonna want, the good thing about Arc is you basically don't have to set up anything. You don't have to set up any ISO drivers. You don't have to play around with different ISO drivers for different compatibilities. Except for maybe there's some games that, well, actually, most of the issues we have are games that have anti piracy protection. We try to we have the Stargate engine which tries to deal with those type of games, but sometimes you have to patch patch the ISO externally. But that's something that's not even related or relevant to the case. But essentially, you don't have to play around with whatever. Like in ME, there's like 3 or 4 ISO drivers. There's the ME ISO driver, Inferno, M33, Sony MP9660. There's a lot of choices. Sometimes users don't even know what to use. And sometimes some games will have issues with one driver that's not with the other one. With Arc, we decided to only have one ISO driver. For custom ISO, if we're speaking about ebu.pvp, the PSN format, that uses the official unmodified Sony MP9660 driver. But for everything else, that's basically the scene equivalent, which is ISO, CSO, ZSO, JSO, DAX, etc. We use one single driver, and the philosophy behind it is because if we focus all our attention and efforts on that one single driver, that driver is going to get much better than if we have to maintain 4, 5, 6, 7 different drivers. And that ended up being true. That's why now we have Inferno 2 instead of the classic original Inferno that we had when we started the Arc 4 project. So it's a lot better, it fixes a lot of bugs, it improves and optimizes a lot of algorithms. So taking that decision of maintaining only one ISO driver instead of multiple eventually paid off. And now we have one single ISO driver that's pretty damn good. So basically, you go to the memory sticks page and everything's set up for you. You don't have to configure anything. Even in terms of homebrew, legacy homebrew, for example, 1.50 homebrew, you don't have to enable any corrupt patch or any corrupt icon patch. It's built in. It will detect corrupted or special files, and it will just ignore them, hide them, etc. For example, those pesky macOS metadata files, those get completely ignored. And yeah, basically, there's really not much to it. You don't have to modify anything else. You don't have to change any setting or anything, and it'll just work. For example, I'm gonna boot up this homebrew here. This is a 1.50 homebrew. Like if I disable Leda, let me disable Leda one minute. If I disable the Leda plugin, try to boot up this legacy homebrew. It'll try to boot it up, but cause it'll cause a bug, an error code. Where is it? There we go. See, we're gonna play it now. We enable Leda. The Leda plugin is now, I mean, it's not built into Arc per se. It's basically literally just the plugin configured alongside the rest of the custom firmware files. And that allows us to distribute the plugin and make sure that everybody has support for 1.50 homebrew, at least some support. And also to preserve the plugin, because I was noticing that the plugin was going extinct, so to speak. It was getting harder and harder to find links for it. So I said, yeah, let me pack it up with art. And here we go. I'm not going to be showing the custom launcher here because I'll be showing it on the PS Vita soon. So in terms of this, of what I wanted to show here on this PSP, I think I'm pretty much done. I'm going to go to another one of my PSPs because I want to show another feature that's pretty damn cool. And it's one of the last features I baked alongside scene member Lucid. Pretty cool guy. So basically, Lucid asked me if it was possible to have UMD video ISOs show up in the video section alongside your your other MP4s, etc. Much like how you have game ISOs showing up. These are all game ISOs. You have game ISOs showing up in your game section as if you had installed them in the native format. So it took a while. We were lucky to get where we got because on my PSP Go, I have it right here. On my PSP Go, we found out I found there's this video, this instructional video, was like a welcome tour, basically, of the PSP, and the video was on the PSP Go's internal memory. It was basically something that came with the system. You can delete it if you if I had the bad luck of that person formatting the PSP Go, I would have never seen that video. And why is that video so important? Because that video, even though it's a .mp4 video, it actually uses a very rare proprietary MP4 format created by Sony. And that rare proprietary MP4 format made by Sony had this very little nice quirk that it allowed you to have a PNG icon embedded into the MP4 file itself. And that was useful because if we didn't have that, then we wouldn't be able to have our UMD video ISOs showing up in the XMB with their icons, as you are seeing right now. Right, so these are all UMD video ISOs, which in classic custom firmwares like Pro and ME, you would have to go to the VSH menu and select them, and that's ugly. It was broken. It caused major graphical glitches if your ISO file was too long. It didn't support ISOs with file names that had special non-Latin characters, so no Russian characters, no Chinese characters, Japanese characters, forget about it. Not even something like the Spanish ñ or the French cedilla, I don't know how it's called. Not even those can be shown if you're using the classic Pro ME custom firmware. With ARC, you have them all showing up right here as if they were PSP, as if they were actual files, MP4 files. They show up as the system thinks it's MP4 files, but they really aren't. And when you try to play them, so let's try to play any random one, Dark Knight, for example. What it's going to do is that the system's going to reboot. Instead of opening the media player, it's going to reboot. And you're going to be seeing that the ISO appears mounted as if you had inserted the UMD movie itself. And you can play it. Right? So just doing a reset VSH is enough to unmount it. And so it goes back to normal. All right. One more thing. I'm gonna be showing different features on different PSP models just to show you that ARC works perfectly with every PSP model, but most of the features I'm showing you are available on other models. Now I'm gonna be using the PSP Go. And why am I using the PSP Go? Okay, so let's turn it on. A year ago, well, not exactly a year ago, but in the last PSP HDC, there was only one way to permanently modify a PSP. And that was using the very popular Infinity tool, which worked great. It did the job perfectly. And a lot of people say that it has like a longer boot time. Yeah, but it's not really that noticeable. The thing about Infinity is that it runs later in the boot chain. It's basically an exploit that runs in the boot chain, but it's already late in the boot chain, meaning there's a lot of things we don't have control over. For example, if you want to replace the entire PSP firmware, we couldn't do that unless you had a 1K or a very early 2K. Well, we had new CIPL already working up to the 3G, but we couldn't, for example, unbrick easily. So with new software, with new hacks, exploits found by other people, the reset hack, the double soar exploits. I'm not exactly too sure who found them. Probably more than one person. I don't want to mention. I'm pretty sure Davi, Balika, Second Sal. I don't want to say too many names because I'm being a bit ignorant here. But all these people, they have contributed a lot, both in terms of software and hardware, to create the Baryon sweeper capable of unbricking every single PSP out there. The last one to be unbreakable was the PSP Go. So now, as I'm showing you right now in my system settings, when I go to system information, you're gonna notice that right now it says ARC4 CIPL. It's not using Infinity anymore. It's now using CIPL. What's CIPL? Well, CIPL stands for Custom IPL. And what's the IPL? The IPL is the initial program loader. It's one of the first things that run in the boot process, and it's the thing that basically is in charge of booting up and loading the PSP kernel. If we can customize the IPL, we can literally boot up whatever we want from cold boot. Like we have full access to the entire chain of the boot process from scratch, from zero. We are basically totally masters, so to speak. We can do anything and everything. We can replace every single firmware files for equivalent unsigned PRX files, for example, and they're gonna work. And one of the cool things about CIPL is that because it runs so early, like it's literally the most early you can run. And because CIPL is also the very first thing installed on the PSP NAND, it's installing the very like the first few sectors. I believe it's after the MBR, the first few sectors. That's where the IPL is. It's not in Flash 0, Flash 1. It's not in any of those Flash partitions. It's the very first thing. And because we have control over it, that means if we somehow fuck up any of the Flash 0 partition of Flash, especially Flash 0, where the kernel is. So imagine you format Flash 0 or you delete the folders inside Flash 0. That's the equivalent of deleting system 32 on a Windows machine, or system whatever, or the Windows folder on a Windows machine. You're deleting the core of the OS. So that's an instant brick. And with Infinity, you would have a brick, and that's it, game over. Because Infinity resides inside Flash Zero. It's an exploit in the boot sequence of the kernel, not before the kernel. But because the IPL is before the kernel, both in the boot sequence and in NAND, that means that if you somehow destroy your Flash Zero, as long as CIPL is intact, you can always just hold down you have to install DC10 first, but I have it installed in this machine. I have let me show you if I can. It's pretty awesome. It's let's see if you can see it. It's 128 megabyte. That's megabyte, not gigabyte. Okay, and that's more than enough for a DC installation. Now I hold the L trigger and I power on the machine. This might not work because that SD card is a little bit problematic and sometimes it doesn't detect it, but if it doesn't work, oh, look, it's working. Cool. If it doesn't work, I'll just shut it down and try again. So this is something that in the last PSP HDC, this would have been a dream come true. This is Despertar del Cementerio, which for the non-Spanish speakers, it translates to awakening from the cemetery. It's a very classic tool created by none other than Dark Alex himself. And this tool allows you to unbrick any PSP. Well, previously you could only use it on fats and slims, early slims. That was DC8 was the last release by Dark Alex. After that, Balika reversed engineered the project and released DC9, which added support for every 2G and 3G, which is the early 3Ks. After that, after figuring out new CIPL, new MSIPL, all of that, I updated. I basically took off where Balika left. Balika stopped his project, and basically I just took off from there and finished it using specially tools created by the V. So basically, I noticed that both Balika and Davi had like half of the puzzle, more or less. So it was a matter of grabbing the pieces that they both created and putting it up all together and making it work. And here we are, running DC10 version 10 is the one that I released on a PSP Go. And look, I can right now install 6.60R. Basically, it will reformat the Flash partitions and install our custom firmware directly. I can install the official firmware version, 6.61, or I can boot the entire 6.61R custom firmware from memory stick. I'm gonna try to do right now just to show you that it just works. If this thing doesn't want to hash out, it's a very old M2 and it's 128 megabytes. That's old. Sometimes it doesn't want to read it correctly, but I don't have anything else, so it better work. All right. If I go to system settings, you're gonna see that in system information, instead of CIPL, now it says DC, because we're running ARC4, but we're not running it from Flash. We're not running what's installed on the PSP NAND. We're running it directly from the M2 memory stick. The 128 megabyte M2 memory stick that I just showed you is running ARC4 entirely, and the 6.61 kernel. All of that entirely from there. And it works really nice. You have the entire firmware, the entire custom firmware. So everything works. And okay, so let me go to another device. We're almost done. Okay, only 2 more devices left. I'm gonna try to go speed things up a bit, but it's just too much that has changed since the last presentation, and I want to really finish everything that's related to test driving it and showing it up in this presentation, because in the next year my presentation will be mostly focusing on the source code, on reading and explaining the source code. Okay, so this one is a 1K or 1000 model. Right now it's running the latest Arc4 CIPL, and it has DC installed. I installed a DC10, but it also has this cute little thing called the Arc 1.50 or Arc 150 add-on installer. Now, what's this? This basically is the entire 1.50 kernel installed on your memory stick alongside a very special version of Arc that runs on the 1.50 kernel. And what that will allow you to do is that you can dual boot. So you have your 6.61 firmware on your NAND, and then you have the 1.50 firmware on your memory stick, and you can reboot into it at any time. As you can see, I have the special custom firmware stuff here because this PSP doesn't have an extra setting. It used to have an extra setting, but then I converted it to or DEX, and after that, it stopped having a, probably because it changed to the VSH region, probably changed to debug 1 or debug 2 or something like that. If I change it to Europe or America or Japan, Korea, whatever other region that has an extra section, and I reset VSH, you're going to see how the extra custom firmware stuff is moved over to the extra section, where it looks nicer in my opinion. See, now we have all this. We have the reboot to 1.50 ARC, and if I click on that, all of this technology is basically the culmination of everything that PSP hackers have ever done. So, like for example, the Reboot 1.50 stuff is done using Time Machine, much like how Time Machine is used in DC to boot the 6.61 firmware from memory stick. And as you can see, I'm on 1.50. I go to System Settings, I go to System Information. It says 1.50 ARC4 custom firmware. And if I press select, I'm going to have this very tiny, very cute VSH menu that only really has shutdown device and reset device. We can probably add a lot more things to this custom firmware. We can add, for example, a clock speed to change the clock speed in VSH in game. We can probably add an option to hide the MAC address or and stuff like that. But I mean, nobody has ever done a custom firmware for 1.50 except for Dark Alex himself, who created a POC, a proof of concept. It was actually called like that, 1.50 POC, proof of concept custom firmware. And though for the time being, our custom firmware, our 1.50 custom firmware, only runs in Time Machine, so you can only boot it up from memory stick. Eventually, we want to create an installer that you would be able to install ARC plus CIPL on top of a 1.50 kernel PSP that's on Flash 0. So if you want to go back to the past and install the entire 1.50 kernel on your PSP and forget about 6.60, etc., you'll be able to install this tiny ARC4 version. But for the time being, we only have it available on the memory stick, so via Time Machine. So no full permanent Flash 0 installation for now. And it comes with all the patches you need. For example, it redirects access from PSP game to the PSP game 150. And this allows you to organize your games. So your 6.60 games go in game in the traditional game folder, while your classic legacy 1.50 homebrew, you will put it in the game 150 folder, and the ARC 150 custom firmware will detect that folder and it'll load everything from there. So you don't have all the 6.61 stuff showing up here. You only have your 1.50 homebrew. And yeah, this is PSP Filer for 1.50, Super Tux for 1.15. Let me boot that up. You can see the classic game boot animation. A lot of this stuff is actually new to me because when I bought my first PSP, it was a 2K model that came with 5.00, or I installed 5.00 M33. So I've never actually had a nostalgia for the 1.50 kernel like other people do. Oh, look at that. The thing crashed. Yeah, this sort of stuff happens all the time. The game crashed, but the custom firmware seems to work fine. Yeah, it's working fine. Right, so that's PSP 1K. You might ask yourself, why the 1.50 homebrew? Well, there's a lot of stuff that we cannot do, even with custom firmware on modern models and modern software. One of those things is being able to do raw dumps of of UMD disks. And for some reason, for whatever reason, I wouldn't be able to explain the technical details because I'm not working on this. But at some point, Sony changed the UMD driver, and that means that you no longer have access to some partitions when you're running the in game mode, for example. So creating a 1-1 dump of UMD is still preferred to be done on 1.50 because the driver allows you to create a 1-1 dump with every partition, preserving every partition. And this is mostly useful for UMD files, you know. And we've worked together with the UMD preservation project, with people like Lucid. I've already mentioned him. They're building this new homebrew for to be able to create these dumps. I believe is it called UMD Rescue or UMD something like that? And yeah, it's good that we're providing them with all the tools that they need for their preservation efforts. And yeah. Okay, so the last test drive is gonna be on the PS Vita, mostly to show the custom launcher a little bit. Even though I've already shown it since last year, but I'm gonna show the custom launcher anyways a little bit. Okay, so on PS Vita, there's two types of installations. One of them is standalone, which comes with two different bubbles, one for PSP games and the other one's for PS1 games. And there's the Adrenaline Arc Hybrid, which basically runs Arc inside Adrenaline, where Arc replaces the ePSP side of Adrenaline. It replaces Adrenaline's ePSP custom firmware, but it keeps the native Vita side of Adrenaline intact. And it also contains a lot of patches from Adrenaline. Basically, it's gonna be like running Arc on a PSP, like the end result. And I'm gonna show it real quick. I'm gonna show it real quick just to show it to you guys. But I'm not gonna be test driving it too much because, like I said, it's like running it on PSP. It's the XMB and all of this stuff that I have already shown. Yes, sometimes it crashes on this stage. I don't know why. Probably some. I believe it was a plugin that if you have installed on Adrenaline or some setting that if you have on Adrenaline, it'll cause this issue. I've known a lot of people having this issue, but it seems to be like a. Let's wait for it to actually. There we go. It could probably be random. Let's try again. I haven't used my PS Vita in a long time, so it's possible that it has some stuff that's broken. Oh, there we go. Now it's working. Okay, so it's basically the PSP. So it's Adrenaline, but it's running Arc. It's basically go to system information. It's 6x61 Arc 4 Adrenaline, and the model is I call it VPSP. I call this environment VPSP because Adrenaline reminds me of VWii on Wii U, where you have the entire Wii system menu and all of that. Adrenaline basically gives you that same experience on the PS Vita. So that's why I call this the VPSP model. And it's basically like on a PSP. Not much more to show here. Um, we still don't have support for UMD ISO video. So don't even try it. They will show up. They'll probably show up if you copy them. But they'll fail to play back. We have come to the conclusion that PSPEMU or whatever other native side of the PS Vita is denying PSP the ability to decode videos that are a higher resolution than the PSP had, which was 480 by 272. And UMD video has a higher resolution. It was something like 720 times 512 or something like that. Okay, so standalone Arc has two versions, the PSP version and the PS1 version. These are basically the classic way of using Arc. Originally, Arc started out as basically pro custom firmware for the ePSP, for the Vita's PSP emulator. And the Vita's PSP emulator has a highly modified PSP firmware, and that highly modified PSP firmware does not have the XMB. And because it did not have the XMB, what the solution that came forward back in the day was to create our own launchers, our own menus, and therefore a lot of menus pop up. Neuron created one called V menu. Yash created another one called Y menu. Gbot created two, G menu and 138 menu. The One Lua team created another menu called One Menu, which eventually became the standard menu for Arc 2. And then finally, when the Flow, back then he was called Total Noob, with TNV, he managed to get the PSP XMB working by creating a sort of hybrid firmware between the original PSP firmware that has the XMB and the PS Vita's built-in firmware that doesn't have the XMB, and with a lot of patches and a lot of figuring out a lot of stuff, so it worked fine. And it was a success. It was a hit. But I personally saw the potential of menus in the sense that it can be very highly customizable. We have the source code. We can change it whatever we want. And basically the inspiration for this menu that's called Arc menu is basically PPSSPP. I was inspired by the menu in PPSSPP, and as well as I knew that PSP users wanted to have a PSP XMB like experience, so the navigation is like the XMB, except you don't have one column, you have three columns. One is for PSP games, the other one is for Homebrew, and the other one is for PS1 games. So it's categorized, and like I said, it's cool that we have this alternative because the XMB isn't always reliable. Like I said, on PSP Go, if your internal memory dies, the XMB is gonna be a hell of a headache. Meanwhile, our custom launcher will work fine in, in those cases. And standalone Arc specifically has a plugin where I can have games installed on EF0. Now, EF0 is actually the internal memory of the PSP Go. Now, this isn't a PSP Go. This doesn't have any internal memory. So what I did was, because the our custom launcher already has support for an EF0 drive, an EF0 device, a device named EF0 from PSP Go. On PS Vita, what I do is map that EF0 device to something else. In this case, because MS0 is mapped to the SD to Vita adapter, I have mapped EF0 to the original PS Vita memory stick. So you have two devices at the same time, and you can access both at the same time. And it works pretty damn well, except for PS1 games. For some reason, it doesn't. They don't want to work on EF0, and could be various things. I haven't really looked much into it. Could be many things. I haven't done any debugging, but I know that PSP games and PSP Homebrew in EF0 work fine. For example, let's see if I believe this one is in EF0. Yeah, this one is in EF0. I can run it just fine. There it is. And the same for games. We have a key combo, which is basically LR down and start, and that brings you back to the custom menu. If you do LR down select, on PSP, it's supposed to bring you back to the XMB. PS Vita doesn't have an XMB, it'll just actually exits you back to the live area, which is the Vita equivalent of the XMB. Now, for PS1 games, now why does ARC have a separate section for PS1 games? Well, that's because PS1 games on PS Vita work a little bit different than on PSP. They are basically the same emulator. Sony was they were bastards. I'm gonna use that word because they stole our idea. Well, not my idea, but the idea that Colbert and the Flow had back in the day. So both Colbert and the Flow, independently, both at the same time, eventually they joined efforts, and something really cool came out. Both of them back then, they didn't have PS1 running on PS Vita. Sony never had PS1 support in PS. This has crashed. PS Vita is such a horrible system. Why did you crash? No reason for it to crash like that. Okay, so oh yeah, that's right. I have a lot of plugins that cause stability. Anyways, like I was saying, originally when the PS Vita came out, and I remember this very well. It had zero support for PS1 game. It did not have any PS1 emulator built into it. Sony never spent money on creating a PS1 emulator for the PS Vita. They had PS1 emulators for ARM devices before the PS Vita. They had one working on the what's called Xperia Play hybrid phone. I don't know why they didn't port that over to the PS Vita. We'll never know. What they did do was literally copy the idea that hackers had. So hackers like the Flow and Colbert, they realized that the PS Vita's PS1 emulator is basically, the PS Vita PSP emulator is basically not an emulator. It's a mix. Okay, it's basically the PS1 CPU and GPU by hardware, and everything else done by software. Peripherals and everything else is done by software. Which for games, it doesn't matter because games never have direct hardware access to anything other than the CPU and the GPU. Well, they don't have direct access to peripheral. They do it via the kernel. So since they do it via the kernel can then pass that over to the Vita CPU, the native Vita side, and Vita can handle all of that. So so we have CPU and GPU only in hardware. It's more than enough to consider the PS Vita sort of PSP model, special PSP model. So what they did was they grabbed the PS1 emulator from PSP. I'm talking about Colbert and the Flow hackers. They grabbed the PS1 emulator from PSP and they made it work on the Vita, but there was a downside. The PS1 emulator on PSP uses the media engine, the ME. We've already had a presentation before about the ME, so it's nothing new for you guys. However, the PS Vita doesn't have the ME. Why? Because it doesn't need it. It doesn't have the PSP ME because it doesn't need it. PSP games, like retail PSP games, never had direct access to the ME. What they did was basically if they wanted to use the ME, they didn't even know what that is. All they knew was that they needed to decode an MP3, they needed to decode some MPG video, some audio, whatever, and they ask the PSP kernel to decode it, and the PSP kernel just has the ME doing all the decoding. On PS Vita, instead of sending the decoding to the ME, is sent to the PS Vita native hardware. That means that any custom ME code does not work. It cannot work because there's no ME, meaning that PS1 games using the original PS1 emulator for PSP had to be patched so that they could not use the ME. And by doing so, they lost sound because it's what they used the ME for. They used the ME for the SPU emulation. So basically, we had soundless PS1 games, but we had PS1 games way before Sony officially supported PS1 games. We had PS1 games running at full speed, but they were just soundless. They had no sound. So Colbert had the idea to port the PEOPS SPU plugin, which is an open source SPU plugin, and it's pretty widely used. It's used in PCSXR. It's used in many other emulators. You can use it in EPSXE. It's an open source SPU PS1 SPU plugin, and Colbert actually created that, ported over that SPU plugin, and the flow also helped him improve the plugin. And while this plugin is basically useless nowadays because we have better PS1 support, I'm going to show it right after this. I am going to show it here because it's still a pretty damn impressive piece of hacking technology that we were able to get PS1 games with some sound working way before Sony did. And Sony eventually copied our idea. So for example, this game right here, Bushido Blade, I believe this one has pretty much perfect audio. Yep, works pretty damn well. Okay, Bushido Blade, Tekken 3 also has good audio. Many other games don't have good audio or don't have audio at all, so it wasn't a perfect solution at all. I've tried a lot of these games, and most of them, some have slowdown, some because I mean it makes sense. You're now using the PSP CPU to emulate PS1 sound when the original emulator used a separate processor. So what Sony did was they copied the idea of hackers, and basically, I'm gonna open Video Shell while I speak. So basically, what they did was they grabbed our idea, and yeah, we didn't have the source code for the PS1 emulator like Sony did. So Sony grabbed the source code of their PS1 emulator for PSP, made it work on the PS Vita's ePSP, and the sound SPU they just redirected it over to the native PS Vita. So basically, essentially the same thing they did with audio and video decoding on PSP games, where the decoding process is done in the native Vita side. On PS1 games, the audio decoding is also done on native Vita side. Everything else is done by the PSP, by the PSP CPU and the PSP GPU, which means that whenever you are running an official PS1 game, this one for example is an official PS1 game that I bought. Whenever you run this, you're not running a native PS1 emulator for PS Vita. No, you're running the PS1 emulator for PSP under a very limited, very special environment. But it's still the PSP. So that means that eventually we found a way to hack the damn thing back then. It was a group effort between me, Quick Racer 87, God rest his soul, and Total Noob, now known as The Flow. And it's one of the best hacks we've ever come across because it was basically so funny. There's a write up on Wololo if you look it up that I made explaining the entire process. Basically, it works because the PS1 games on PSP run almost natively. Not fully natively, but almost natively. Basically, because the PSP has a CPU with the same architecture as the PS1. So most of the time, it's running PS1 code natively. So if you have a PS1, so if you have an exploit, a vulnerability in the PS1 code, it's going to translate really nicely into a vulnerability into the PSP side when the PSP is executing that same code. And I'm not gonna go into all the details, but this technology was almost lost. Like the ability to run custom firmware inside the PS1 emulator of the PS Vita was almost lost. The only time in the PS Vita history where we have something like this was back in when the Flow released TNX, which was basically a custom firmware using the exploits that Quick Racer and I found. And I recovered this. I recovered that technology from the TNX source code that I had on because the Flow gave us this. The Flow was very open with us all the time, as well as we were with him. We would share source code all the time, and I had the source code lying around on my email on my Gmail account, and I would manage to rescue it before it gets deleted, and it's actually uploaded in the PSP archive. You can find it too. It's called CEF PSX, custom emulated firmware for PSX. And what I did was I mixed it up with newer technology. In this case, Chovy Sign and No PSP DRM, and another plugin that I created alongside a fellow developer, Silica. Basically, it allows for PS1 custom firmware to revive, be useful again, because Sony made a lot of limitations that prevented us from running PS1 custom firmware again. I'll never understand that. PS1 games were much older than anything else they were selling on the PlayStation Network, yet somehow they managed to be the most secure of anything. It was crazy. Sony was like burning a lot of money on stupid shit like that. It's very stupid shit like that. Like it's dude, we're only hacking a bunch of 20-year-old games, 25-year-old games. Come on. But yeah, I mean, we're talking about the same Sony that didn't even like have buy loader, a homebrew enabler, something that only allowed you to. It didn't allow you to do piracy at all, and they didn't like it. So yeah, Alright, so I'm gonna launch it now. And again, this is created in collaboration with the Chovy project. It uses Chovy sign, it uses some other modern techniques. And you're gonna notice that this is not the same custom launcher as the other one. This one uses its own custom launcher that's separate from the one that we use on PSP, mostly because there's a lot of limitations. There's a lot of stuff you cannot access. It's it's a PSP, but it's a very limited PSP. For example, you cannot whatever you draw on the PSP frame buffer, you're not gonna see it on screen because the PS Vita ignores whatever you're drawing on the PSP frame buffer. It only shows on screen what's being drawn on the PS1 frame buffer. So every time a PSP homebrew has to update the screen, you have to grab the PSP frame buffer and translate it into the format of the PS1 frame buffer. And that takes a toll in the frames, for example, because it uses CPU to do that redrawing. And we do have the GPU available, but I don't know. We never bothered to figure out how to do the redrawing using the GPU. What we did was we created this specific menu that it also gives you a very nostalgic vibes. It kind of does look like something that came out for the PS1, even though what you're looking at right now is PSP homebrew. This is PSP code. This is not PS1 code. But as you can see, the screen and everything, the colors have been changed back to 16-bit. The screen resolution is the same as the PS1, so it's drawing like if it were a PS1 right now because it's, like I said, it's limited. We cannot output audio because, like I said, it handles PS1 audio. It doesn't handle PSP audio. But that PS1 audio is perfect. So we can run any game, run some random game like this one. Totally random choice. And you're going to see that it has perfect audio. Because now we're using what we nicknamed Vita Pops. It's basically the Pops version of the Pops for PS Vita. All right. Think I've shown basically everything. Well, last thing. We can use plugins. So mostly CW shit, and that's about it.
Great, thank you very much.
So any questions? Do we have time for questions?
I would say if people have questions, it's probably best for them to do so in the Discord.
In the Discord, right? Yeah. Yeah, I agree. Yeah.
Okay, then. Thank you very much.
Yeah, you're welcome. Awesome.
Okay, then. Thanks everyone for being there. That was our last presentation. I hope you had a great time, and